All right, y'all, do you see what's going on there? Do you see the countdown?
Yeah.
Hey guys, let us know if you can hear us. Let us know if you can hear us. Maybe you can't yet. They can?
Yeah, I just heard it.
All right, put your mute on. Here we are, guys. This is our first time on Brent Explains. Say hello, everybody. We've got Brent in the house. Hello. We've got Mario. Hello. We're using StreamYard for the first time, guys. We're using StreamYard. So, ladies and gentlemen, welcome to the very first big live stream here on Brent Explains. Tonight, we are asking the kind of questions that make your brain hurt in the beginning, but in the best way possible. We've also got Jimmy over here from Jimmy Explores. Say hi, Jimmy. You guys don't forget to vote. You can vote. Are we alone? Are we alone? Now, I'm new to StreamYard, so I don't know if can anyone answer. Can y'all answer those questions?
It's a little delayed, but it's still good.
Yeah. Tonight we're asking the kinds of questions that make your brain hurt in the best way possible. So, are we alone? Why did everything come into being? Right? Why does everything exist in the first place? These are big questions. These are very big questions. And we're using a new service. It's called StreamYard for the first time. So Mario, how do you think I'm going to do, Mario? Do you think I'm going to be able to handle it?
Yes. We've been learning this.
Hold on. Let me make sure your mic's on.
Can you guys hear us?
Now I can hear you guys.
Hi, hello guys.
Yeah.
Thank you for joining this live stream. Yeah, I
Jimmy,
think
did you drop something? You
Yeah,
guys,
but
Jimmy, classic 14-year-old. Go on, what happened? Oh, you have got your buzzer. You guys, we have buzzers as well. So go on, Mario. What you're saying?
We're learning StreamYard, but so far it's been a nice experience. So,
yeah, it's been pretty cool. So you guys let us know what we could be doing better. This is our first time going live here, so subscribe.
Right.
Thank you, David Young. Glad you guys can hear us. You guys are so cool for joining us over here.
Yeah, guys, thank you for.
If you're brand new here, we have an audience over on Jimmy Explores. And so this is our usual setup. So we have, again, Mario. Say hi, Mario.
Hi guys.
We have Brent. Hi. Hello, that's me, Brent. It made me put a name down here.
Yeah.
So I have a name, but I'm using StreamYard for the first time. So you guys help us out by subscribing to the channel so we can get this channel monetized. And then we have Jimmy. Here's Jimmy. Hey, Jimmy, how are you? Jimmy, make sure you don't pick at your face because we don't want you to get acne, right? So make sure.
I was itching my face.
Okay. Well, same difference, you know. But are we alone? Where did everything come from? How could life on Earth have started? Could have started from somewhere else? Are UFOs proof of aliens, or are we just bad at identifying weird stuff in the sky? And why do movies like Interstellar, Arrival, Prometheus, Alien Contact, and 2001: A Space Odyssey make the universe feel even more mysterious? So Brent is behind the producer desk tonight. I'll be pulling up the visuals, asking the trivia questions, reading the chat, launching polls, and throwing Mario and Jimmy into the cosmic courtroom. So if you guys are watching live, you're not just watching the show, you are part of the show. So make sure you drop your answers in the chat, vote in the polls, and if you, well, you can't send a super chat on here, but you can send a Venmo. So if somebody wants to leave that in the comments, I'll put it here.
Don't forget to also like the video, guys. And subscribe to this channel as well. We're going to have a really interesting conversation tonight. So
it's going to be really cool.
Yeah.
It's going to be really cool.
And we want your thoughts too. So.
Yeah, this is our first time on this channel. So we need you guys, all the people, to convert over from Jimmy Explores. So I'm Brent behind the producer desk tonight. And welcome to Brent Explains. Tonight we're doing exactly what this channel is built for. We're taking big, complicated, fascinating ideas and making them understandable, fun, and worth arguing about. This is not going to be a boring science lecture. Tonight is science, movies, mystery, trivia, debate, and speculation about where we're going. But we're going to keep the rules very clear. We are going to separate fact, theory, movie magic, and pure speculation. So we're not just like going to be like all ancient alien-y and be like blah 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 blah. We're gonna like have fun with that stuff, but also at the same time really dissect the thing. Jimmy,
Right.
do you ever think about space?
Yeah.
Yeah, you do think about space?
I mean, not rarely.
Not rarely or not often?
No, like just rarely I do.
You think about it rarely? What do you think about when you think about space?
Planets, galaxies,
Yeah.
oxygen.
What's the difference between a planet and a galaxy?
The galaxy is like where all planets are at, I think.
Mario, can you explain what a galaxy is according to your knowledge?
A galaxy is like the conjunto, like the group of solar systems
Mm-hmm.
that are orbiting around. I think it's a black hole.
Yeah.
What tends to be at the center of a galaxy,
Yeah.
like orbiting around it. So a planet, it's a much smaller piece of it.
Well, a galaxy is a massive gravitational bound system made of stars, stellar remnants, interstellar gas, dust, and dark matter. Okay. Ranging from dwarf systems with a few thousand stars to cosmic behemoths with trillions of stars.
Yeah.
They are the fundamental building blocks of the universe. Galaxies are. So galaxies are the fundamental building blocks of the universe. Did you know that, Jimmy? Mario, I think he has a little bit too much headroom.
I can adjust it.
Yeah, just
really
a little bit
quick.
so he has headroom.
Yeah.
Our home is the Milky Way galaxy. So, Jimmy, we're in the Milky Way galaxy.
I know.
Okay, so you did know that. All right. So, why do you think it's called the Milky Way galaxy?
Because the way the galaxies look.
Well, they call it. It's whenever they first looked at it, it looked like a milky,
That's what I
mix
just
of
said.
stuff. Mario, what do they call the Milky Way galaxy in Spanish?
La Vía Láctea.
La Vía Láctea.
Vía Láctea would be like
VIA.
Yeah,
It's like a railway train. It's like the same word.
Yeah, Milky Way. Yeah.
Yeah. So let's go over what type of galaxies there are, since Jimmy doesn't really know fully what a galaxy is. And that's okay. There are spiral galaxies. That's one of the classic ones is a spiral galaxy.
Yeah.
You guys let us know if you can hear the music too. This is our first time using StreamYard. This is our first time going live on this channel as well.
Yeah.
So if y'all are new here, subscribe. But they're spiral galaxies. They're characterized by a flat rotating disk with luminous arms that curve outward.
Mm-hmm.
They are rich in gas and dust, making them active sites for new star formation. Then there's the elliptical one that's rounded or an oval-shaped galaxy. And I'll cut to a galaxy.
I think the Milky Way is elliptic, isn't it?
Say it again.
I think the Milky Way is elliptic.
I have to see.
I don't know.
Or is it a circle?
I mean, there's nothing. None of them are classified as a circle.
Right, but like the arms that you mentioned.
Yeah, I think it's like a circle.
So the Milky Way galaxy is a barred. It's called a barred spiral galaxy.
Okay.
This means
it's zooming in. I didn't even realize
this means that it has a center, a central bar-shaped structure
I think
made of
that's what ours
stars,
looks like.
bright, curved arms, and gas, dust, and billions of stars spiraling around from a giant pinwheel shape.
Yeah.
So there you go. There's that. So it's a spiral and a barred one. So that's both. It has a flat spinning disc with bright curved arms and that radiate outwards. And then rather than the arms connecting directly to the core, they emerge from the end of a thicker linear bar.
Gatsby, I am new. I need to hear something that's not rebranded to feel confident to sub.
That's not rebranded?
Yeah.
I mean, we do
What does that
great
mean?
content here, Gatsby. So.
I don't know.
What do you mean by rebranded? Hey, Gatsby Tango, I am new. I need to hear something that's not
like we
rebranded.
copied somebody else's stuff. Like,
I don't think we're rebranding anything. Let me know what you mean, though, Gatsby Tango.
But welcome. To the channel.
Yeah, welcome. This is we have a channel called Jimmy Explores. So, but this is like an extension of that channel.
it looks like it's in Washington.
It's a pretty stunning view of the stars. You know, whenever I'm in a big city, I think of the universe because it's harder to see the stars on bigger cities.
You think about it more when you're in the big city.
Yeah,
We're
'cause-
supposed to have a really big meteor
I-
shower tonight.
I feel like I think about it more when I'm in the country because you see, like, the city lights like prevent you from seeing the stars.
that's why I
right?
think about it more because I miss the stars when.
Because you miss them.
We're supposed to have like a big meteor shower, like 100
tonight.
100 meters in like
That's
a
kind
minute.
of scary though, because it's
Yeah.
like, what if there's a meteor that they missed?
Although
We're
it's
supposed to have
quite,
like a lot,
yeah, it's quite,
like 12 a.m. through 5 a.m.
yeah, it's quite. I mean, it happens. I think
But I don't know if we're gonna see it in Mexico.
quite often. I don't think we were just talking about like the pollution.
'Cause I saw like the image on where you could see it. Or like
Yeah.
the Dallas area, you're not gonna be able to see it because there's gonna be like clouds in the sky.
Mhm.
Well, here's a true or false question for you. The Big Bang was an explosion that happened in the middle of empty space.
Yes.
True. I think, yeah.
All right, so you're saying true.
Yeah.
So the Big Bang was something that happened in the middle of empty space.
Uh-huh.
Did you
Yeah.
know it's actually false? The reason why we call it the Big Bang is it's the way our universe started, but we're inside of a bigger universe. So the
Mhm.
Big Bang theory is not that nothing exploded into everything. It's actually quite different. What it's saying is that it was the rapid expansion of space itself. There was no outside or empty space before it, but it's just we're explaining, like, that's why there's the theory that we're inside of a black hole, right?
Right.
That everything that we know, our entire universe, is inside of a black hole.
Mm.
And so
Mhm.
that's the idea. Speaking of a black hole, I've got a black hole here
Don't-
for you.
Say it.
What are you talking about?
I think
I'm not making a joke here. Jimmy,
No.
you're here for the jokes.
No, I thought you were gonna say, well, I have a black hole sitting on. I'll switch to the camera. Because he's eating all the food. His stomach is a black hole.
Oh, you thought I was going to refer to you as a black hole?
Yeah.
No.
You know.
Listen, I'm nicer than that. So this is like a depiction of, like, kind of like that. This is a similar image to Interstellar. It's not
Yeah.
Interstellar, but it has like some similar imagery going on over here.
speaking of which, that movie is quite famous for the depiction of the black hole.
It really is. It's very
Um,
famous for its depiction of black holes.
Yeah, and
Hmm.
because it is pretty accurate the
Yeah.
way it a black hole looks like.
Yeah, it's very accurate in the way that it shows a black hole. 100%. Okay. And you guys let us know if you're able to chat, like, with this poll that we have, because this is new for us.
Yeah,
We're using
as you
StreamYard
can
for the
see,
first
like,
time, and we're
They said
excited to use it.
100% maybe, but not here.
Mm.
But I don't know who voted. I don't know. David
Not
Young
bad.
says Brent. Jimmy said Brent said he's nicer than that, but he made an alien picture of you. So just had to say, I think that was funny. But Mario, do you think that making an alien picture of Jimmy was bad? I think that was something cute.
It's
I thought it was cute. I could have made the alien like monstrous, right?
It was a nice
and it'll
alien.
look more like you then.
All right. What is the what is the official name of fossil radiation left over from the Big Bang that scientists mapped to see the infinite universe?
Fossil fuel.
No, here's the question, guys. So
Carbon
what
14.
is the official name of the fossil radiation left over from the Big Bang
What does it start with?
that scientists used? Cosmic.
Cosmic.
Some people are going to know this. Yeah,
Cosmic
like
fuel, I
DAG
don't know.
overhaul. DAG overhaul.
Cosmic
DAG overhaul. You see,
background.
I'm using all these new tools here. But so here's the question. What is the official name of the fossil radiation left over from the Big Bang that scientists
background?
mapped to see the infinite universe?
Cosmic background.
That's right. The answer is
Good job, Beck.
cosmic
I got it
background.
from Dag Overhaul.
Cosmic microwave background, to be specific. Cosmic microwave background.
Oh yeah.
I've heard of that.
Yep. Or CMB.
Can,
All right.
Yeah.
All right. Which element was created in the absolute highest quantity during the Big Bang?
Nitrogen.
You're close. That's good. That's a
Hydrogen.
good one. All right. That's your guess? Is hydrogen?
Oh, it said he said. Repeat the question.
Jimmy, what is your guess?
No, say the question again.
All right. What is the official name? Sorry. Which element was created?
Element.
Which element was created in the absolute highest quantity during the Big Bang? Which element was created
So the
in the
elements are
absolute? You
air?
guys, look at this. Subscribe just for this cutie patootie. All right.
What?
It's
It's
the chemical.
John Scott got it. Mario got it.
No,
It's hydrogen.
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 What did you
was-
say?
Hydrogen, from as far as we
I don't
know,
even know what you said.
as far as we know, that is the most that was created. Like the highest quantity element was that.
The atmosphere is still quite a lot of hydrogen, like,
Mhm.
isn't it? I think, like, the atmosphere is
Yeah, there's a ton of hydrogen.
made out of a lot of
That's the
hydrogen.
biggest element that we know of that
I think.
exists, right? Is hydrogen.
Yeah,
It's the simplest element, says Dag Overhaul. Yeah,
Yeah.
very good point. It's the simplest element. All right. True or false? The universe is currently cooling down as it expands.
False.
True.
True or false? The universe is currently cooling down as it expands.
False.
I think it's true.
It sounds true because like once you more expand it more, it can like spread. But
Yeah.
I think it's false.
You say you think it's a trick question?
I think it's false.
Okay.
That's
Is global warming?
Did
I
it
don't
let
know.
y'all vote, by the way, on the poll? Are
on
we
mobile.
on,
No, Mm-mm.
on the poll?
No.
No, for us, no.
So then maybe it's
Maybe it's computer only, or
No.
yeah.
or-
I don't know, but I can stop the poll.
What's the answer?
There are two people that voted on.
Oh my God, it
so
landed.
We'll see. There we go.
But is it true or false?
It's true.
Oh,
The
I
answer
mean,
is
it sounds
it's
true.
true. Yeah, it's like entropy. Yeah, Dag Overhaul. You're right. Although I have a theory that like everything's been expanding and exploding over and over again, like over and over again. So I think that the universe is constantly exploding, and I think it's just a nonstop thing. It's constantly going like that. John Scott says you disenfranchised me.
Oh, David Young said you have to type 1, 2, or 3, or 4
Oh,
in
into the comment section. Oh, okay,
Wait,
good.
redo the poll. Let me see if I can do it.
All right, I'll do it 1 second.
that makes sense
That
Alright,
makes sense.
because I
who
saw
would-
some comments that
Uh-huh.
were like,
I like it. All right.
Thank you, David.
And then I can this is why we're doing this. All right. So I'm dropping here and like I can show this on the screen. There we go. This is why this is cool, right?
Yeah.
All right. Who first proposed the theory that the universe started from a single
Whoa,
primeval atom?
that's cool.
A
That's
priest or
nice.
an astronomer?
That's cool.
Shadow, isn't this cool? All right. So who first proposed the theory that the universe started from a single primeval atom?
I don't know.
I would say priest just because it sounds like it's
Like
the
it
answer.
sounds like a trick question. Like the
You know,
answer would be priest.
Yeah.
I'm gonna say the most random answer.
Okay. So tell us.
Albert.
No.
You're thinking of what, Albert Einstein?
I think it was.
I mean, that wouldn't be random. I wouldn't call Albert random.
way
No,
before.
David Young says his phone is at 5%. All right, y'all leave us Venmos because since this channel's not monetized yet, I can still highlight your comments. But the answer is both.
Mm,
George Lemaitre was a Belgian priest, and he was a priest and an astronomer. I think that's the best of both worlds, right?
yeah.
Like, wouldn't it be the best? Wouldn't it be better to be both? Like, just in case.
Deviant, he didn't make the light bulb.
When both science and
Mhm.
religion, can
If first-
coexist.
Oh,
I also think it's. I mean, it's not
Mhm.
not contradiction necessarily.
Yeah,
but
I think science and religion are totally compatible. I think it's like the way you interpret things. Religion itself is up for interpretation.
who made the light bulb?
and
Edison.
both can be
Huh?
considered a philosophy too,
Yeah.
to some extent. So yeah,
Mm-hmm. All right. So the next question is: in 1929, Edwin Hubble discovered what the galaxies are doing which proved the Big Bang Theory.
oh, like moving or
Okay.
expanding.
Yes, that is the answer. I'm going to go ahead and put it here. Blunt says the sheer scale and variety of the cosmos cannot be encapsulated by a single localized framework state or from observer. That's right, Blunted. And there's a lot of great conversations out there about this, but yeah, like it's unfathomable how big the universe actually is.
Yeah.
Here's Jimmy. Say hi, Jimmy.
Yeah.
So here's the answer. I'll show it on screen. In 1929, Edwin Hubble discovered that galaxies are doing what, which proved the Big Bang Theory. The answer is that they're moving away from us and each other. So
Yeah.
Mario, you hit the nail on the head, or as they say in Spanish, le diste el clavo. Le diste el clavo.
Right.
I'm very excited because of all these new tools that we have. So if you guys have not subscribed, subscribe.
Subscribe,
Because we're going to
guys.
be doing
Thank you.
lots of really cool stuff here. And we had to just jump in head first with this because this is our first time using StreamYard, which is letting us do all these fun, cool things. All right. So what is the ultra short, faster than light expansion phase of the early universe called?
What?
I'll put it on the screen so you guys can see it.
Yeah.
Yeah.
Uh,
Gabriel is at home. We've got to get him to learn his English. We got to get him to learn his English. Because that's the only way he can participate fully. So Gabriel was one of our regular cast members. We love Gabriel. We love him, and he's growing his channel. So I'll see if he's available to come in tomorrow or day after tomorrow. All right. So here's a question: what is the ultra short, faster than light expansion phase at the early universe called? John Scott says expanding the Big Bang. So it is part of the Big Bang, but there's a word for it. It's called cosmic blank.
Cosmic background.
People joke about it, like they joked about it recently on Star Talk, because they were saying like the president's always saying that it's not that bad. What is bad? What happens to your currency, Jimmy? What if something happens to your currency? Inflation. So it's called cosmic inflation.
Cosmic inflation. Okay.
But I'll accept expanding and Big Bang. Why not? But the answer is this. It's cosmic inflation.
Cosmic inflation.
All right. This is our known universe, but how old is the universe? How old is the universe?
Approximately 3.2 trillion years old.
Like 200 billion.
Y'all, I mean, how do you say you're close or not when you're in that range, right?
Okay, was I close?
What did you say?
3.42 trillion.
No.
Is it on the trillions?
No, it's in the billions of years.
3.42 billion years old.
2,000
Y'all
billions.
subscribe just how cute this kid is. All right, so say it again, Jimmy. Your guess?
3.42 billion years old.
Okay, well, the answer, this is like the known universe. And David Young got
200 billion.
David, did you cheat? Be honest. David, did you Young?
Oh.
David Young, did you cheat? It's cosmic inflation. Dag Overhaul says that's what happened to Marge and Harry Potter. You guys don't forget to comment, because your comment can make it onto the big screen. All right, so here's Dag Overhaul's comment. Comic inflation. He called it comic inflation. That's what happened to Aunt Marge and Harry Potter. Because remember, she expanded. Remember that, Mario? Again, floated away.
Yeah.
That's hilarious. So David Young said it. David Young hit it on the head. It's at 13.8 billion. What were the only three elements created in the Big Bang before stars existed?
Hydrogen, nitrogen.
CO2.
All right. Here's the question. You guys, no cheating.
Hydrogen, nitrogen, and helium.
What were the only three elements created by the Big Bang before stars existed? Like before stars even existed, what were the three elements that were created in the Big Bang?
What's that gas that's like in between the atmosphere?
Well, there's lots of gases, but I'll give you a hint. One of them is like if you put it into your throat, you're talking like this.
Helium.
Yeah, so it's hydrogen, helium, and guess what the other one is? Lithium.
Lithium.
Can you believe it? Dag Overhaul got it. Dag Overhaul, very good.
Good job.
Y'all chats for Dag Overhaul. Very
good.
Lithium
is well preciado, like well.
Mm-hmm. Lithium
like
is a big deal, yeah. Like lithium is a big one. But it's interesting because lithium, we use it in batteries, we use it in all different kinds of stuff. So here's the answer. It's hydrogen, helium, and a tiny bit of lithium. But hydrogen and helium were created the very, very first start of the Big Bang. All right.
Mario said helium multiple times.
Yeah. But I was waiting for the third one. And I'm doing a lot over here. I add everything that I was doing before and now add this. And so, but good job, Mario. Very good job. Okay. All right. Next. All right. The center of the universe is located exactly where the Big Bang happened. True or false?
The center of the universe?
The center of the universe is located exactly where the Big Bang happened.
False. Does the universe has a center?
Is that true or false? The center of the universe is located exactly where the Big Bang happened.
I think false.
Yeah.
It's false.
Yep.
The Big Bang happened everywhere at once. There is no single center.
Yeah, because there's
How do
no
we know that? I mean,
center.
I think that's also because I think that the Big Bang applies to our black hole that we're living
What's up,
in,
Rob?
too. Hey, Rob, how are you?
Hi, Rob.
You're right. It's the Big Bang happened everywhere at once, so there's no single center, right? There's
It's
no
like
single
the center is the observer, I think.
Well, right. It's like whoever's observing it, because it's infinite. I think it's infinite upon infinite upon infinite. The best way I know to explain it is the end of Lucy, when she gets to reach 100% usage of her brain, and like whenever you see the universe being created and inside of a black hole, everything is existing inside of that black hole. So Rob, there you are on camera. Rob, this is our first time using this. So there you are on camera.
What do you mean?
Rob says he's eating Taco Bell. Be with you later.
Oh, that's cool.
That's funny.
That's cool.
Yeah.
Dag Overhaul says space is infinite, but matter isn't.
Right.
All right. What is the name of the era immediately following the Big Bang, before the first stars turned on? This sounds like a joke, but it's a real thing.
The first century?
No. Good job, John Scott. All right. If you guys are new here, subscribe to the channel. You can participate. This is our very first live stream.
What is the name of the era immediately following the Big Bang? The Big Bang? Is it called the Big Bang?
The small bang.
Look how cute this kiddo is. All right. So you're saying it's the Big Bang, Jimmy?
Yeah. Big Bang era?
The bang.
The Big Bang era?
Yeah.
Dag Overhaul says, I don't know this one. Apparently not right now. Hello. The answer is called the Cosmic Dark Ages.
Oh.
Okay.
Now this sounds like a joke, but I think that actually is what it's called.
But you know, you could put like
David Young, you're right. He's like, says this
Brent,
this channel is not monetized yet, but you can help with Wise if you're international or on Venmo. That's true.
Brent, you know, you can like do automatic chat, so to just automatically pop up on there.
Yeah, but we don't want necessarily everybody, right? But you guys, if you're new to the channel, but Rob, let us know that you're eating Taco Bell. I love that.
Thank you.
Shadow says, good night, Jimmy, Brent, and Mario. I really enjoyed the live stream tonight, my friends.
Good night, Shadow.
Thank you, Shadow.
Hey, Shadow. Shadow, what time is it? Where you are? If you could hear the cosmic microwave background radiation on an old school analog TV, what did it sound or look like? This answer, I think, is pretty easy.
What did the sound look like?
Static.
Noise? Noisy?
Static, I think.
Yeah, the answer is like static snow, like on the screen. Basically, like that poltergeist looking stuff. John Scott says the cooling period. All right, so if you could hear the cosmic microwave background on an old TV, analog TV, what would it sound or look like? Yeah, static or snow on the screen. How much of a delay is there?
It's like
5 seconds.
5 seconds.
Yeah.
All right.
Actually,
which fundamental?
Probably like 10 seconds.
Okay. Which fundamental force of nature is the weakest, even though it controls the shapes of galaxies?
Gravity.
Okay. I'll let everyone else.
Eric, can you put it on here? Which fundamental force of nature is the
Good night, Shadow.
Good night, Shadow.
All right. So which fundamental force of nature is the weakest, even though it controls the shapes of galaxies? Which fundamental force of nature is the weakest, even though it controls the shape of galaxies?
Gravity.
All right. I think Mario was the first to say gravity, right?
Yes.
Okay. Yeah.
I think.
I got it from John Scott.
Love. I agree.
John Scott said gravity.
I agree.
Dag Overhaul says love. Love. All you need is love.
I agree with you, Dag.
I love that.
Guys, somebody donate $50.
Y'all can go to Jimmy Explores. Y'all can. Yeah.
I can get a haircut.
Yeah. If we get this keyboard, just randomly went into Spanish. Business.
It's probably like a command that you accidentally did.
Yeah, probably.
I didn't get like my hair trimmed up here and then. Because up here I leave it long so this grows more. Like it grows longer because I left it long, but these sides grow.
But you're right. The answer is gravity. The answer is gravity.
Get
Get perms.
I did an AI picture of me with a perm, and I really did not look good.
But you didn't look good in the original picture either. You took it from a bizarre angle.
I remember
when you did that, you took like a strange picture. You guys can also go to Jimmy Explorers and leave super chats on Jimmy Explorers. All right, so next, so you're right. The answer is gravity. It's a fundamental force of nature, but it's the weakest, even though it controls the shapes of galaxies.
I'm just learning that it's the weakest because I know gravity also determines the shape of planets, but I didn't know it was the weakest fundamental force.
Mm-hmm.
It'll take long. I know it'll take long, but once the perm once I grow out my hair and it like straightens out, I'll do it again if I don't like it.
All right, so here, the fundamental forces of the universe. There's gravity. There's electromagnetism. There's strong nuclear force and there's weak nuclear force. So it's a real thing. So it's very interesting.
Right.
I watched a whole video about this and it was mind blowing. It really will blow your mind. These kinds of details.
Yeah, I was thinking about. I was actually when I was like in the 6th grade, I was thinking about getting a perm, because like it's like a low taper.
But why would you get a perm? You've got such a great hair.
Why would I get a haircut?
Well, what I'm saying is like it's such a unique, decision to make.
You were literally the one earlier. It's like, oh yeah, you should get a perm.
Oh yeah, like I was not advocating for a perm. Come on, be for real.
Do you remember when he said that? Mario, be honest. Yes.
Did I say that? Maybe I was saying it for like as a joke, right? All right, here, guys.
I mean, it's not bad.
Nice.
So this is what I was. This is Mario. I was like wondering how fast you could do this, but like, look, this kind of stuff. Like, I'm gonna change this song. So these are the forces of the universe.
Oh, right.
Right.
I love that. So gravity, strong.
Guys, I mean, that's not bad. Look.
So look, I can make this full screen. So there's electromagnetism, there's weak interaction, and the interaction is called nuclear force. It's like, or called force. There's it's either protons or neutrons, and then gravity is the weakest. But the interaction, there's like a whole video on that, right? So that's its own thing.
All right, bye, Shadow.
That would be
Good night, Shadow.
Thing. Okay. All right. So what temperature was the universe at the exact moment of the Big Bang? So what was the temperature of the universe at the
1,000
exact
degrees
moment?
Fahrenheit.
Million degrees.
So the temperature of the universe was at the exact moment of the Big Bang. Was it freezing, boiling, or infinitely hot?
Infinitely hot.
Actually, you know what?
Because it's cooling, remember.
I want to say freezing.
What do you want to say?
Because listen.
You want to say? Okay.
You know how like you freeze something and something it like explodes?
Yeah. Yeah, I feel you, bro.
Or it could be burnt really hot.
Because it's cool.
Because like if you have a rock, right, and you throw it into a fire pit,
okay,
all the moisture inside of it boils and it explodes.
Okay.
I would say.
So I'm gonna say infinitely hot then.
Yeah.
Well, he's right. The answer is infinitely hot. Can you believe
it?
Can you give us the reason why?
I can.
Because
all right, so listen to this.
Because if the Earth, listen, let me speak.
Sure.
Because if the Earth had a lot of water,
yeah, there was no Earth at that time, though.
No, I know, but like water.
Yeah. What about water? The water didn't exist.
I mean, there was hydrogen, lithium, helium.
Okay, well, give us the answer. Give us the reason.
I think
at the exact moment of the universe, it was infinitely hot, according to the standard Big Bang model. Okay. Why? Because all matter and energy existed and were crushed into an infinitesimally small singularity, because this state packed an incomprehensible amount of energy into zero or near zero volume. The temperature theoretically approached infinity, right? And there's also like levels. Did you know there's levels of infinity too? They talk about this on Star Talk.
Probably.
Like there's literally several levels without infinity.
The faults are inner stars too.
Well, you can go beyond.
Yeah.
You can go beyond infinity.
Because because
there's 5 levels of infinity.
because heat creates energy, right? So
Uh-huh.
it makes sense to have.
Well, the temperature is essentially a measurement of the average kinetic energy of particles compressing all the
Yeah.
energy of the universe into an infinitely dense point. Forces particles and radiation into unimaginably close proximity, causing the temperature to skyrocket.
Mm.
And then there was the cosmic expansion. So modern observations like the leftover heat from the cosmic microwave background, the CMB that we call it, that microwave background that Dag Overhaul talked about, confirm that the universe is in fact expanding. And when you wind this cosmic clock backwards, the universe shrinks. Shrinking the volume that energy occupies naturally increases its temperature. So shrinking the volume that energy occupies,
Mhm.
it naturally increases its temperature. So it would have been infinitely hot at the Big Bang, the exact moment at the Big Bang.
Right.
Note, as the universe expanded outward from the initial singularity, it cooled rapidly. Within the first second, temperatures fell from theoretical infinity to roughly 10 to the 10th power Kelvin. Today, the average temperature of space has cooled to just 2.73 Kelvin, or negative 270.42 degrees Celsius.
Well,
So that's about
It's like way below freezing, right? So
no, like in Fahrenheit. I'm trying to calculate in Fahrenheit.
I mean, like the scale in which Fahrenheit works is also interesting.
Mhm.
So that means it's like 5 negative like 350.
There, well, how you have it on screen here.
I never learned
today,
how to convert Celsius to
Let's see,
Fahrenheit.
No, what is it in Fahrenheit?
negative 270.42 degrees Celsius.
No, in Fahrenheit.
Oh, in Fahrenheit?
Yeah.
Oh, I don't even know.
I think it's like 350.
0 Kelvin is negative 405.59.70.
It's negative 404. Wow, this is pretty cool. All right, here you go. There you go. Here's your answer, Jimmy. Oh, dang. The way it places way too much.
0.67.
God dang.
I know that 0.67.
Which one's the answer?
What is going on? Glitch. Hold on.
What is going on?
Listen, this is my first time, you guys, not hosting, but using this program. So y'all give me a break off.
Hi,
that
David
Kit Kat
Silars.
bar.
Hi, David Sellers.
Hi.
Hey, David, how are you?
I live near the river Kelvin. I think
Here-
Lord Kelvin may have owned everything here. Ooh,
Yeah.
nice.
All right, here it is. The average temperature of outer space is negative 454.8 degrees Fahrenheit,
Okay.
or negative 270.4 degrees Celsius.
Okay.
So there you go. So why is deep space rest at this specific temperature? Is because the temperature is the residual thermal radiation left over from the Big Bang, which fills the entire universe uniformly.
Mm.
So there's a lack of matter. Space is a non-perfect vacuum. Without dense matter like air or water to absorb and hold heat from the starlight, it cannot maintain a warm temperature. And the proximity also matters.
Yeah.
This extreme cold applies to only to deep space, far away from stars. An object in direct sunlight near Earth can heat up to over 250 degrees Fahrenheit or 121 degrees Celsius. So how about that? Rob, are you still having your Taco Bell? Are you here?
Rob, if you want to DoorDash some Taco Bell, we don't even have Taco Bell here. That's Mexico, so that
we
makes
do
sense.
need to. Yeah, we need some food.
Taco
to
Bell
eat,
existed
whatever.
here, but they
They
couldn't
left.
compete. Yeah.
A lot of companies.
I'm sure they did. 'cause
Well,
Taco
they
was
make
like-
it. They make it hard to compete in Mexico.
Was Taco
even
Bell-
Best Buy was here. Best Buy was in Mexico. Hey, Rob, how are
Oh,
you?
really?
Yeah.
I guess just nobody bought anything from that.
Jimmy, say hi to Rob.
Yeah.
Say hi to Rob. Hey, Lee Hambleton,
Hey,
how are
Rob.
you? Hey, guys. All right. So, what is the name of the satellite that gave us the most detailed map of the infant universe's CMB radiation in 2013? Remember, CMB is like cosmic microwave
What is it?
background.
Hubble?
I think. Is it Hubble?
Hey, look, Rob's saying hi to you. Rob, there's your message on screen. All right, so Mario, So yeah, I think we need Venmos to get comfier chairs because they've got wooden ends. And we need to have like the comfy chairs, right?
We have the ones that.
Here's the question. Dag Overhaul, that's a great guess.
You know, there's like the single chairs that, like, they're like a couch, but you can recline.
Oh yeah,
that's not cool. All right. So, what is the name of the satellite that gave us the most detailed map of the infant? And the infant universes, infant meaning like baby universes C and B, or that cosmic
Hubble
microwave. It's actually the Planck satellite.
Never heard of it.
PLANCK. So there you go. This is something. Listen, you guys, subscribe if you learned something new today.
Yeah.
Subscribe if you learned something new.
Subscribe, everyone, please. Planck. Oh, okay.
You know, it's weird. Like in Texas, like one day it can be like extremely hot, then the next day it's like cold.
Yeah. But it's the Planck satellite. All right. So how long after the Big Bang did it take for the first actual stars to form? Was it 10 seconds, 100 million years, or 1 billion years? I guess this feels like a trick question because I feel like it's
a billion years.
I will say
actually no, because
John Scott, that was anticlimactic. Well, it's because, but John Scott, you're pointing out that like
what gas
we all this is why nostalgia is such a big deal because we want to know the answer. So if we don't know the answer, it makes like it less satisfying.
10 seconds. Because
that's the thing about like you want to know the answer. So if you don't know, you're like, but it's true. It's 10
seconds because like they're full of gas. They're like a ball of gas. So it's like.
Yeah, I mean, listen, I think you could make arguments about, but when did the actual stars start to form?
10 seconds.
I mean, no, because it
was
100
million years.
It was between 100 and 200 million years. Yeah. And again, I think as we make advancements in technology, we're going to reevaluate a lot of this stuff. And then later we're going to be like, actually, it was this. Or actually, it was that, right?
Essentially, stars are gas, right? So it would make sense that it wouldn't have taken so long, like planets, for example, for what I can figure. Because I'm not sure either. Right. But
so this is a great, it's great to learn the real deal. That's right, John Scott. All right, so this is a great question by Lee Hamilton. So you guys be sure to subscribe and leave comments. So Lee Hamilton says, what are your thoughts on 3I Atlas? So 3I Atlas, if you guys don't know, 3I Atlas is technically named C 2025 N1. It's the third confirmed interstellar object passing through our solar system. Following the Oumuamua or the Borisov, it was discovered in July 2025 by Atlas Survey Telescope in Chile. This ancient cosmic visitor originated from outer space, from outside our solar system, and is yielding remarkable secrets about planet formation in the galaxy. So people don't really understand like its trajectory. It's very highly carbon rich. There's heavy water discovery. Data from the Alma Observatory revealed that the 3I Atlas contains roughly 30 to 40 times the proportion of deuterated or heavy water found in Earth's oceans, providing a chemical window into the freezing conditions of its home system. So the hyperbolic trajectory is really wild. So to answer Lee Hamilton, 3I Atlas is bizarre because it's moving too fast to be bound by the sun's gravity, and 3I Atlas is on an unbound path, meaning it simply came to visit and will exit the solar system entirely. But we don't really understand how or why, which makes people think it's an alien spaceship, right? And it's highly carbon rich. So observers from the James Webb Space Telescope, JWST, James Webb Space Telescope, and Sphere X revealed that the comet is, they call it a comet, but it's not really a comet, is unusually rich in carbon dioxide compared to comets that formed in our solar system. This suggests it formed in an extremely cold, distant environment in its original star system. It's just wild. Wild.
Yeah. You know, I was just hoping that you wouldn't crash into Earth. Yeah. But I remember like back in last year, when there were so many updates on it too, like regarding its trajectory and its composition and everything. So it was really interesting too.
Yeah, I mean, it's very, very interesting 3 atlas for a variety of reasons.
Right.
But
Right.
the biggest of them being its trajectory, its composition, and just
Yeah,
knowing
its
so
origin,
dang little
maybe,
about
yeah.
it. Yeah. hmm So I'm gonna use our new program here, and you guys, your Venmos are welcome to help us out. Here's a picture of 3i Atlas. So that's what they think it looks like, essentially. Now there's different levels of it.
Yeah.
That's one rendition. It's really too far away for us to really look at. Here's a better idea of it. And now this one looks a little bit more like looks a little more spaceshipy. Let me see. I can only share JPEGs, so let me get this.
But yeah, most of these are just renditions because we don't actually have.
Yeah, we don't really actually have it. Yeah.
It. Even for black holes.
I'm looking at them.
Even for black holes, we just got like the first photo of a black hole, like a couple of years ago.
This is literally the closest that we actually have of it is not very remarkable because it's so freaking far away. But I'll show you the image of it. Here it is. But this is that's all we have to go off of is this right here. So Lee Hamilton, did I answer your question?
Yeah.
Deserve a super chat. But that's all we really have to go off of is that right there.
Yeah.
So we have the Uma, we had a bit more of an idea of it. That one was huge. The Uma, the big one. Okay. Very good questions, guys.
Thank you.
Nice piece of intergalactic rock, says John Scott. I agree. Okay. All right. Next. All right. So what do scientists call the theoretical single point of infinite density that the universe expanded from?
Singularity.
You're very welcome, Lee Hamilton. You got it right. It's the singularity.
Let's go.
The singularity. Very good. It's called the singularity.
Yeah, because there wasn't like an actual thing, right? So it was
thank you for watching from Indonesia. We need to come. We were literally looking at tickets for Indonesia. Jimmy, you need to come to Bali, Indonesia. Ferdinand, let me know if you're still there. Those chairs are expensive, David says. These chairs. I mean, these chairs got them out of the place.
No, you're talking about the chairs. Chair. Like he gave us like a link. A link to some chairs that we could look at. Cause you're saying.
Oh, okay. To make them more comfortable, like to make the arm, yeah. But the answer is the singularity.
Yeah. Thank you, John Scott.
John says that the ones at Home Depot says Rob. Okay, Mar is a genius. Agreed. Yeah. All right, so it's called the singularity. All right, so true or false? True or false? Sound waves actually traveled through the super hot plasma of the early universe before the stars formed.
True.
So here's your answer. It's the singularity. But true or false? Sound waves actually traveled through the super hot plasma because at the early ages of this is like where the edge of like Mario's and our knowledge. We know about film history. We know about like this director, that director. We're going back before anybody was a twinkle in anybody's eye, before the creation of anything. Is it true that sound waves traveled through super hot plasma of the early universe before stars formed?
I would say true. Although,
yeah, I said true. Yeah, true.
Rob says, "Let me know when you guys are ready for my important announcement." I don't like to interrupt you, Brent.
What is it? We're ready.
We're ready. It's true. They are called baryon acoustic oscillations. Baryon acoustic oscillations.
Okay, Rob, the stage is all yours.
Jimmy, look at him being all like showmanship. I love that. Look at those books behind Jimmy. You guys don't forget you can support the channel through Venmo. This Stream Deck is useless to me because there's a bunch of junk in there. So I need it to be more You see what I'm saying? It doesn't help me.
No, that's when we first got it, and that's when we like.
But yeah, I mean, for me, the answer was kind of tricky because I wasn't sure like what was causing the noise or the sound.
There was noise from the bang itself. It's just that, but the idea was like, what was it? Was it? What does it does? It was echoing and ricocheting, I guess, off of the plasma and what was existing, like you know.
If you guys
it was
come
not
here in
stardust
October, we
yet.
will look for a house for you guys. I'll give you $100,000 for a down payment to purchase it.
That's amazing. Thank you, Rob. That's amazing, Rob. So that would be in Wilmington, Delaware. So thank you, Rob. Appreciate that so much. Truly, that's no small thing. So that's amazing. It's making me teary-eyed. So thank you. What is the term of the process? So you guys, if the people that are new to the channel, on Jimmy Explorers, they know that we lost our house in LA with the fires, etc. But we don't have to keep talking about it because it's like, you know, but at what point does that become like your narrative, right, Mario? It's like you have to like move on. But thank you, Rob. That's huge. What is the term of the process? If you guys want to support the channel, you can go to Venmo.
Anywhere out here, you don't have to pay me back.
Thank you so much. That's amazing. Thank you, Rob. Hate when you guys are trying to record during the birth of the universe and these baryon acoustic oscillations ruin your sound. Dag Overhaul, you're hilarious.
It happened to me. Dag Overhaul.
That's funny. These are Dag has always been very super intelligent. So it's like, let me do this. Like, let's go next level. All right. So what is the term for the process where the first stars stripped electrons from hydrogen atoms, ending the cosmic dark ages? So there was a time called the cosmic dark ages.
Yeah.
All right. So what was it called?
Cosmic dark ages.
It's not that hard of a term.
The cosmic strip.
I like that name, the cosmic strip, or the cosmic strip tease.
Yeah.
I bring the brains. Rob brings the bank.
I love that.
Rob, we're counting on you.
I love that.
All right. By the way, here's ways to support the channel. But the question is, what is the term of the process where the first stars stripped, meaning took electrons from hydrogen atoms, ending the cosmic dark ages? I'll give you a hint. It starts with the word re-I. John Scott says illumination. That's a good guess, John Scott. Reionization.
Reionization.
It's called reionization.
Reionization.
Mm-hmm.
Okay.
It's called reionization. All right. All right. If the age of the universe were compressed into a single calendar year. Okay. So if the age of the universe were to be compressed into a single calendar year, January 1st, starting on January 1st, on what date would modern humans appear? If the entire age of the universe were compressed.
So are you saying like each day is 1 billion years?
Well,
or like, what do you?
Here, I'll put it right here for you so you can see it. So
like
you have a good point of reference here.
The whole age of the universe, yeah.
But
like, what's the calculation of like which day, like how they spread out?
It's on screen for you.
April 24th. No.
Thank you, Rob. I believe you. I think you, Rob. I really do. All right. If the age of the universe were compressed into a single calendar year, starting on January 1st, on what date do humans finally appear?
December 31st. Yeah.
Mm-hmm. Yep.
Is it?
It's not even it's like at the very end. Like humans don't even appear until like the last second.
Yes.
Because humans are just, it's so late.
We're so young.
So yeah, we're so new. And look how long it took us to destroy ourselves. No. All right. So what forced the four fundamental forces of nature, gravity, electromagnetism, strong and weak nuclear forces, to split apart in the early universe?
Oh my gosh.
This one I'll tell you. I'll go ahead and tell you the answer.
Yes, that's a hard one.
I know it would be hard to live in an area you're not familiar with. Thank you, Rob. I appreciate that so much.
Thank you, Rob.
And thank you, Rob. And in the meantime, we are getting by because we have to make these big decisions. So any support is welcome, especially now that we're on this channel. So if you guys are new here, subscribe to the channel. All All right, so listen to this. What forced? So all the forces, everything was one thing, right?
Yeah.
So all of the universe, everything was one thing. But what forced the four fundamental forces? So, oh, here it is. And I put the answer: the cooling down, because I was like, this is too hard. This is kind of too hard to really answer.
Cooling down.
But the cooling down is what separated the four fundamental forces of nature. So there are only four. There's gravity, electromagnetism, strong and weak nuclear forces. And the weakest of them all is gravity. Which is pretty wild.
Right. That was a hard question.
It was pretty hard, yeah.
Because I would think of the fundamental forces as...
Well,
like
people don't even
the
realize that
top.
there are other forces.
Right.
Like people just don't realize. Okay. All right. So you guys let us know if you like this topic too. If you like talking, if you like this kind of star talk type of stuff going on over here.
That's Lee Hamilton. That's what we try to do here.
Lee Hamilton. It says, I think Jimmy is learning more from Brent than he ever could at school. Thank you, Lee Hamilton. I appreciate that so much. I really, really do. So thank you for that.
Thank you.
All right. So next, so we have the four fundamental forces of nature, which are gravity, electromagnetism, strong and weak nuclear forces, and they split apart at the cooling down of the universe. All right. True or false? Light could travel freely across the universe immediately after the Big Bang.
True.
False, because it would need for the universe to keep expanding, I think, to...
Rob says he likes to watch this kind of stuff on TV, like maybe like science type channels, things like that. So I'll go ahead and give you the answer for this one because this is a tough one. So the question was true or false. Could light freely travel across the universe immediately after the Big Bang? And the answer is false. The universe was thick, opaque fog of plasma for the first 380,000 years.
Jeez.
So things didn't immediately. Right, Dag Overhaul, that's the question. Freely, like freely. That's the question. Freely. Could they do it really freely? That's the big question. Jimmy, what do you think about the comments on screen? I mean, as it was diffracting it. That's right, Dag Overhaul. All right. What property of a galaxy tells us how fast it's moving away from us based on the stretching of its light waves? There's a term for it. It's called something shift. What property of a galaxy tells us how fast it's moving away from us based on the stretching of its light waves?
The
redshift.
Dag Overhaul, you got it. Dag Overhaul,
wow.
You got to go to Jimmy Explores and leave a super chat. Come on. It's redshift.
That's really cool, Dag Overhaul.
Dag Overhaul, you're a boss. You're a boss. Want to show us your buzzer, Jimmy?
One way.
People love the buzzers. So, what property of a galaxy tells us how fast it's moving away from us based on the stretching?
One way from Delaware to Texas flight cost $419. Mexico City to Texas only costs $180. That would be a lot for you and Jimmy each time for Delaware.
Yeah. That's from We Them People. Thank you, We Them People. Appreciate you being here. Yeah. And then Rob says fair prices change. That's very true. They do change.
The redshift.
The redshift.
Okay.
Right. So what subatomic particle? So you guys, I'm learning a new system here. So we appreciate you guys being awesome with us.
Thank you guys. Also, don't forget to like the video.
Yeah, don't forget to like and subscribe. All right. So what subatomic particle collided and destroyed each other constantly in the first seconds of the universe?
Both Philadelphia and Dallas are both hubs for American Airlines.
Both Philadelphia and Dallas are both hubs for American Airlines. That's good to know. All right. So it's basically like the Doppler effect of sound, but with light frequencies. Dag Overhaul. If you could leave a super chat, I would invite you to. But you got to do it over on Jimmy Explores.
Or Venmo. I know you're in Sweden.
Yeah. All right. So the answer is matter and antimatter.
Oh, okay.
So these were constantly destroying each other. And again, a lot of this stuff is like, you could say it's theory.
Yeah.
You know what I mean?
Yeah.
You could argue that it's theory.
But it
All
makes sense. Because
Yeah.
there wouldn't be like
Hey, the art.
any other particles yet.
Hey,
I
the art.
think.
Hello, how are you?
Hi, the art.
John Scott says neutrinos. He's just trying to say neutrinos.
Those are like the smallest.
They're like emitted from the sun.
I think
I'll let you
those
know.
are the smallest particles, I think,
Um,
of matter.
all right, neutrinos are tiny, abundant subatomic particles that has almost no mass and carries no electric charge because they rarely interact with normal matter. Trillions of them pass harmlessly through your body every single millisecond, even without you ever noticing. But I have a theory that that's what causes aging.
Mm.
Like, I think we age because neutrinos.
That's what Mom said too.
Mom said that too?
Mhm.
I think that's because we talked about this. But like neutrinos are constantly passing through your body.
Yeah,
So
that's what
like,
my
they're
mom said.
like trillions of them. So imagine, Mario, I don't think that can happen without having some effect on your DNA.
Mm.
Do you know what I mean? So I think there's a theory. So, but I don't think that a lot of people think that. That's just been my theory for like since I was in my 20s or so. Is that neutrinos? Neutrinos are one of the things that cause aging. It says a neutrino is a tiny, abundant subatomic particle that passes through you and carries no electric charge because they rarely interact with normal matter. But if trillions of them are passing through you constantly, come on. But they've got a ghostly nature to them. They only interact with matter via gravity and the weak nuclear force. And there's different flavors of neutrinos. They come in 3 types: the electron neutrino, the muon neutrino, and the tau neutrino. We can go. That's a whole rabbit hole right there. But if you guys like science, we can do this. But I'll give you the highlight right here, and then we'll move on. But this is what neutrinos are. But that wasn't even the answer to the last one. It was the matter and antimatter, right?
Yeah, matter,
but I
antimatter.
think quarks are the smallest. What was the question? You said what was the smallest element, or what was the smallest?
Like the smallest particle.
Yeah.
Or matter division, I think.
All right, let's ask that question. What is the smallest subatomic particle? All right, it says the art says I believe gravity ages people's skeletal makeup. Gravity takes its toll, but actually without gravity we would die because you need gravity to like create muscles and things like that. So like if there was no gravity, that's why people can go to space. Like you need gravity. All right. So what is the smallest subatomic particle?
Micron.
Oh, good guess.
John Scott, they're constantly passing through us. So I think that you'd have to find like a way to
All right, is it microns?
They're quarks and leptons. According to modern physics, these are considered the fundamentals, meaning they have no internal structure or measurable physical size. They exist as zero-dimensional mathematical points. And again, this also kind of shows us that. Let me see what's going on, Jimmy.
You know, you can get solar panels from this brand. You can just plug them straight. You can plug it straight into here like the other ones.
So here, the smallest subatomic particles are quarks and leptons, according to modern physics. These are considered fundamentals, meaning they have no internal structure or measurable physical size. So it cuts off, but they exist as zero. Mathematical points.
Input.
That shows you though that like why the Big Bang Theory is such a big deal.
Yeah.
Because it's like if there's basically the building blocks of everything have no weight. Right. So which would make us believe, well, it's very easy to conceive of everything being in one giant boiling point.
Yeah. Although that also sounds like theoretical to
on the
me,
generator.
at
No,
least.
I can't.
To me, because it's like, how do you even like know that they're there? Like, how do you compruebas like that they're there?
Compruebas means like proof.
Proof, yeah.
Proof. Yeah, well, it's because of the Hadron Collider and things like that. All right, so here we're doing into a debate and speculation, guys. Debate and speculation. Jimmy is lifting up a generator that we bought to go camping. So if anyone wants to help us sponsor our camping trip.
It's actually a good workout.
That's heavy, yeah.
That's like
no
10
way,
pounds.
but consumes everything, says Dag Overhaul.
How much do you think this weighs? 10 pounds?
Maybe 12.
All right. Is space expanding? What is if space is expanding? What is it expanding into? This is for debate, guys.
Nothingness.
Yeah.
Like a vacuum.
A new
vacuum.
New
Lee
galaxy.
Hamilton says, love this channel.
Black
I'm here
hole.
for Jimmy and Brent, but it's so educational as well. Thank you, Lee Hamilton.
Thank you, Lee.
Thank you, Lee.
Hamilton.
This is our very first live stream on here.
Thank you, guys.
All right. So thank you, Lee Hamilton. All right. So what is he says the heat death of the universe, says
infinity and beyond.
All right. So that people are already answering. They're saying infinity, the death of the universe.
I think nothingness, like
so space, technically space is not expanding into anything because it encompasses everything that exists. Instead of expanding outward from an edge, the intrinsic expansion of the universe means that the metric dimensions between objects simply is stretching. Space is expanding into itself.
Okay.
How's that for wild?
This is actually kind of the same size as the other ones, but just like.
So that begs into the idea of the fabric of space-time.
This
According
is-
to Einstein's theory of general relativity, space is not an empty static stage. It's an active, flexible fabric. When the universe expands, this fabric stretches uniformly everywhere. But what I think is amazing is how early Einstein was able to get these concepts down.
Yeah. Even
Right.
before fully proving them,
Right.
these theories were already there. Like,
Right, Rob?
studies.
$100 and I'll get a haircut.
Yeah. Well, we have to go on. That has to be on Venmo because we need to get haircuts. So if anyone wants to sponsor our haircuts, I've been folding over. I've got this extra hair, and I'm like, just like doing this to fold it over. Well, it's interesting because the universe is infinite, which is why like the first trillionaires will be made in space, right? Like expanding into space, and there's so much potential.
But
$1,000 Jimmy gets to cut Brent's hair. Yes.
but I agree, Rob. It's hard to really grasp an idea of how.
So here's on screen
the
for everybody.
universe
According to
is.
Einstein's theory of general relativity, space is not an empty static stage. It's an active, flexible fabric. When the universe expands, this fabric stretches uniformly everywhere.
Yeah.
So that's pretty cool. All
Well, I can't really like do anything like fun with my hair. I have to just keep my hair.
And by definition, there is no outside or boundary to grow into. The expansion simply means the distance between points increasing all at once. Because if the universe is infinite, it curves back in on itself.
Yeah.
Like the surface of a multidimensional sphere, and has no center, no outer edge. You wouldn't hit an edge. You would just fall into nothingness.
And keep on falling.
You wouldn't hit an edge and fall into nothingness.
Forever.
You would simply measure more distance.
Mhm.
So there's a raisin bread analogy. Imagine a loaf of raisin bread breaking in the oven. As the dough and the space rises, all of the raisins or the galaxies move away from each other.
Rob
The
said-
bread doesn't expand into an empty portion of the oven.
Rob
It just
said,
takes up more volume within itself.
Okay.
Rob said, but what was there before the Big Bang?
It's
All right. So what was there before the Big Bang? Okay.
there
You guys-
wasn't nothing, but there wasn't.
All right. Here, Rob has a
Anything
question. It's a great
either.
question. What was there before the Big Bang? Great question. So before the Big Bang, and I'm gonna get a visual here. Let's see if I can save it. There's a lot of files now, like they won't let you save it because they're like WebMP files, but
Yeah.
the JPEGs you can save.
I
but-
mean, there
What-
wasn't something, but there wasn't anything either. It's just like the.
Is that your final answer?
I think, yeah.
Okay, so
That was the
the
question.
short answer is that we do not know for certain, but modern physics strongly suggests that the Big Bang was not an absolute beginning of everything, as the stated cosmic inflation likely existed right before it. Because the hot Big Bang describes the rapid expansion and heating of our early universe, asking what came before it is one of the most profound questions in cosmology. So,
Yeah.
Rob, that's a great question, Rob.
Yeah.
It's the biggest question out there. It's
What
the biggest
was-
question in cosmology.
How much food was there before Jimmy was born?
More than there's now. Physicists have proposed several compelling theories to explain what might have been there. The cosmic inflation theory is the leading theory. Do y'all want to hear about the leading theory?
Yes.
All right. We'll do this, and then we're gonna break for food, and then we're gonna go over to Jimmy Explorers. But we have to grow this channel. So if you guys have come over here from Jimmy Explorers, you gotta subscribe.
Subscribe, guys.
Yeah, you gotta subscribe because we're moving over to Jimmy Explorers. All right, here is the cosmic inflation theory. This is the leading theory on what happened before the Big Bang. Okay, so Rob, thank you so much, and you guys, we need your support on. He says I still have leftover Taco Bell. Rob, well, we need food over here. So we need your
Taco Bell?
Okay.
Can you ship Taco
I'm
Bell
gonna Uber
to
eat
us?
some Taco Bell.
So listen to this. Maybe Rob can help us out for food. But listen to this. The cosmic inflation is a leading theory. All right. The most widely accepted scientific model, okay, indicates that before the hot Big Bang, the universe was cold, empty, and experiencing a period of cosmic inflation.
Yeah.
During this phase, space itself contained an immensely high energy density. This energy caused space to expand exponentially, faster than the speed of light, doubling in size repeatedly in a tiny fraction of a second. When this inflation finally stopped, the immense energy driving it was converted into matter and radiation.
Okay.
So there was no matter yet,
Right.
but the energy was converted into matter and radiation. This chaotic release of energy is what we actually call the Big Bang. And then there's the quantum singularity and nothing. A more traditional view based on Albert Einstein's general relativity points backward to the initial singularity, a point of infinite density and heat where all space and time were compressed into zero volume. Imagine zero volume, like no volume at all.
That's hard to even imagine for me.
Under this framework, physicists Stephen Hawking and James Hartle suggested the no boundary proposal. They argue that space and time formed a closed curve, meaning time itself started at the Big Bang. Like there was no time before the Big Bang.
Was the sun part of the Big Bang? Big Bang.
Oh, sweetie, no.
Not
There was
yet.
nothing. There was like nothing. There was like
No, like
nothing.
did it like? I guess it was a star, so I guess it did form it.
It formed way later. See, this is why we're teaching Jimmy, because we want Jimmy to learn this stuff.
No, I know. That's what I just said. So what's a star?
But Jimmy, there was no Milky Way galaxy. There wasn't
I
even
know.
our
Yeah.
So they argued that space and time formed as a closed curvature, meaning time itself started the Big Bang. And this view, asking what was before the Big Bang, is scientifically meaningless. But that's under one theory. That's the quantum singularity and nothing theory. Now, there's an alternative hypothesis. Because our current mathematical models break down when trying to calculate the singularity, isn't that interesting? Like science is proving that there really wasn't a singularity, right? So Rob, leave another comment so I can put it on screen. Because so far, it says the matter that makes up the sun, yes, Jimmy, as well as the matter that makes up you.
Yeah.
That's right. So all that matter was in a zero volume, Jimmy.
So
you guys, thank you for all helping me raise this child. I appreciate everybody so much.
So there have
So
there haven't been new matter created, right? Because matter
no
is
matter has been created except for that what was created at the Big Bang.
Oh, that's
like
crazy.
in that moment, right?
That's crazy.
It is crazy. And so it was like expanding outward infinitely. Jimmy, look up.
you were in the Big Bang, Jimmy.
All right. So listen. The alternative hypothesis, because our current mathematical models break down when trying to calculate the singularity, scientists look to quantum gravity and other possibilities. So there's one called the cyclical universe. Model suggests that our universe undergoes an endless loop of expanding, collapsing in on itself, and bouncing back out of the Big Bang. That's my theory. Is it like forever and ever? It's always been doing this. So there was no the Big Bang before the Big Bang. It was another Big Bang. Like it's constantly expanding, and it just takes forever and forever. But I think that is potentially happening inside of a black hole. So that's one, the loop of ever expanding and collapsing in on itself. So it's like bouncing back and out of a new Big Bang. Okay. Then there's the multiverse theory. I think these can both exist. The multiverse theory is that other theorists hypothesize that our universe is just one bubble in a massive, ever-inflating cosmic ocean. In this scenario, other big bangs are constantly happening elsewhere, creating entirely separate universes. This is actually one of the leading theories beyond, because the Big Bang Theory is it's just one part of like the cosmic inflation idea.
Yeah.
Let's see how much of this lets me put on screen here. This is our first time using this program, so I can put only so much. The multiverse theory hypothesized that our universe is just one bubble. So this is the theory that we did on Lucy. At the end of Lucy, remember how like it's inside of a bubble, and I actually think that is real. But I think inside of that, there's a bigger Big Bang that's happening. So I think it's never ending. So then there's one more, if you can believe it. There's even another one, and it's called the ekbiotic scenario. It's derived from string theory. This idea proposes that our universe was born when two parallel membranes of space floating into a higher dimension collided with each other.
Okay.
Mario's like, I don't even know what to do with that.
I'm just
yeah,
like grasping the idea of.
It's huge. It's like infinitely interesting. But again, it's like, but this is what they were talking about on these channels like Star Talk.
Yeah.
So here we go. Here's this one. This is the one. This is also a very leading theory. So look at this, Jimmy. Look at the screen. The ekbiotic scenario derived from string theory. This is the idea. This proposes that our universe was born when two parallel membranes of space floating in a higher dimension collided with each other. And Mario, there's a way of explaining like the multiverse that we have. And what basically it's like, imagine like loaves of bread. Okay, like a traditional bread, right? And there's slices. And these slices, each slice is like another multiverse, but it's infinite and it goes on forever. But those slices can't interact with each other. But if you reach a certain level of technology, like maybe something, so like these UFOs, maybe it's somebody who's found a way to penetrate the other loaf, right? The other slice of the loaf. But Brian Cox talks about it a lot. He's like an astrophysicist. Like, what was there before the Big Bang?
Right.
So it's pretty amazing.
Yeah.
John Scott says, is a multiverse a self-replicating entity? Not necessarily. Not necessarily, because the multiverse itself would be like, but there's a theory that there's an infinite number of everything. So it's like the amount of everything is, so the idea that we even have scarcity is just so bizarre. But it's because of our limited resources and the way that we're very territorial animals, right?
Yeah.
All right, so you guys,
and at least from Earth, we cannot like create or have new matter,
right?
Also,
yeah, and then there is like wormholes. Yes, that's one way of looking
at it. Wormholes. I mean,
all right. So I'll give another question. Is it possible that our universe is just the inside of a black hole existing in a completely different universe? Is it possible that our entire our universe is just inside of a black hole existing inside of another universe? Jimmy, what do you think?
I guess possible, but yeah, hard to prove, maybe.
Yeah, hard to prove.
Because we don't really know what's inside of a black hole, I think, yet. Or if we, because it bends like light and time, I guess. But yeah, I think it's possible. Yeah, I don't know, because that's not what a black hole is. Yeah, that's another possibility. Yeah.
So this is like a concept of the expanding universe and like a black hole. So there's so many different ways to showcase a black hole.
Yeah.
And what a black hole looks like. Are you hungry, Jimmy? Yeah, he is. He is hungry. All right. If the universe had a definite edge, what would you think if happened if you stepped outside of it? We kind of covered a little bit of that idea, that concept.
It's like you cannot. It is like It's like you wouldn't see anything beyond that, but
Well, there's so if the universe had a definite physical boundary, stepping past it introduces profound paradoxes in physics, right? So there's three scientific theories of the edge. There's like the brick wall edge. Space abruptly stops as a hard physical barrier. Of
Mhm.
course, that's not real, right?
No.
Because it's like if space, there's the idea. Well, if space is not infinite, what's on the other side of the wall when it's done? So space
Mhm.
obviously is infinite, right?
Yeah.
And then there's the infinite void, which matter ends, but empty space continues forever.
Yeah.
That's another theory. And then there's the Pac-Man effect. Like bending space loops you back into the opposite side. Why do they call it the Pac-Man effect? Because it's like whenever the game Pac-Man, when
Yeah.
you're wah, 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 once you leave the frame, you come back into the frame again.
Mhm. Yeah.
So it's the Pac-Man thing. Yeah.
But since it's
Rob
since
says,
it's
"What are you hungry
infinite,
for? What are you hungry for?"
That's a paradox. So there's no answer that makes sense. Yeah.
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 But
Essentially.
so the ancient Greek philosopher Acritus first proposed this thought experiment by asking if he could extend a staff outward at the edge of the heavens. If the staff extends, space exists there. If it cannot, something is blocking it, meaning the barrier exists, which itself must occupy space, right? If there's a barrier.
Mhm.
Therefore, an edge to space logically cannot exist without something existing outside of it.
Yeah.
But basically it's like this sphere idea. It's like everything is like bending back on in on itself.
Kind of like the idea of trying to get to the edge of Earth. Maybe I'm not saying it's the same as the universe, but it's kind of like the idea of the Earth has no really an edge.
Yeah,
I guess it's similar.
Rob says, "Why are you guys making fun of my question?" No, we're not making fun of your question. Are you talking about the other people? It's because Jimmy's always hungry. I think that's so. Jimmy, what are you hungry for? Jimmy, he's one thing he's good about is that he'll kind of eat what we put in front of him. So Rob, he's good. We just like whatever we put in front of him, he'll eat. So we try not to give him slop. We try to give him like decent meals. Rob, I don't think they're making fun of you. But they're not making fun of you. But Rob, any help with meals is welcome, 100%. Truly. All right. So Dag Overhaul says there's another possibility which actually happens to be true. The universe is constantly expanding and you can never catch up with it. So it makes no difference if there's an edge or not.
Yeah.
Dag Overhaul, that's true. But I think if you were like a bigger being, like if you're a larger being and you're like looking at space, let's say like from a God's eye view, that like what would that look like? And they say that it would look like a giant sphere, like this plasmic sphere. But even if that were true, it's like what's out. If you're observing it, where are you observing it from? Right?
Yeah.
It's pretty wild.
Mm-hmm.
Do you think time actually existed before the Big Bang, or is what happened before the Big Bang like asking what is north of the North Pole?
Well, because there are like the time as we conceive it, like typically, and there's also like the physical definition of time, right?
Right.
So I think as a physical definition, it didn't exist. And obviously not as the concept that we have of time now.
Yeah. Yeah, you're hitting one of the deepest mysteries in modern physics. And the reason why is because the north, like what is north of the North Pole is exactly the analogy that Stephen Hawking used. Traditionally, that's how he framed it. Under Einstein's general relativity, space and time are bound together as a single fabric. Because time is a property of our universe. Asking what happened before it is geometrically and logically nonsensical, just as you cannot walk further north once you reach the top of the earth. So once you reach the top of the earth, you can't go any far north, right? At least on earth, right? However, modern cosmology does not have a fully settled answer. The North Pole analogy assumes the universe has a definite point, an infinitely dense singularity. Because we still lack a tested theory of quantum gravity, physicists are actively exploring alternative theories.
Okay.
And here are the theories. And this is how we're going to end the live stream. So Rob, if you'd like to help us out with a Venmo, Rob, that would be amazing. Jimmy, let him know what you're hungry for.
Oh no.
I'm hungry for noodles. I'm hungry for like some Japanese food, something like that. All right, so here are the ideas. Okay, Mari, you ready for this?
Yeah.
Yeah.
I will try to.
Jimmy, get excited because we're about to eat something. Hey, Gabriel Martin Flores, how are you?
Hi.
Super hugs you all. Love you so much from London. Thank you,
Hi.
Gabriel Martin Flores.
Thank you.
Gabriel Martin
There is a
Flores.
storm by us.
There's a storm outside.
Ooh.
There's a storm, everyone. All right, so you guys get this. This is going to be a really great way to end this live stream, and then we're going to go on Jimmy Explores. So listen to this. Under Einstein's general relativity, space and time are bound together as a single fabric, right?
Mhm.
So we covered that.
Yeah.
All right. However, modern cosmology doesn't have a fully settled answer. The North Pole analogy assumes the universe began as a definite point. But these are the ideas. There's the cosmic bounce, the multiverse, and the string theory.
Mhm.
Okay, the cosmic balance. This theory suggests the universe undergoes an infinite series of expansions and contractions. This is the one I was telling you that I was thinking, but it's called cosmic balance,
Mhm.
and where it's the universe is constantly expanding outward and bending back in on itself. So this theory suggests the universe undergoes an infinite series of expansions and contractions infinitely forever, meaning our
Mhm.
Big Bang was simply the rebound of a prior collapsing universe.
Yeah.
But then again, if that's true, when was the first one?
Yeah.
Then there's the multiverse theory. It means the multiverse is our Big Bang might not be an absolute beginning of everything, but rather a localized event, like a bubble popping into the existence into an eternally expanding multiverse where time extends indefinitely. That's the multiverse theory. I think there's some ways for all these to be true. So this is on screen right now. This is the multiverse theory. And then there's string theory, which a lot of people are really into string theory.
Mhm,
And that's
yeah.
the membrane theory. And this model proposes a pre-Big Bang state dominated by fundamental strings and fields that are evolving, that were evolving long before our visible universe began expanding.
Mhm.
And so I'll put this on screen. And you guys don't forget, you can support the channel through Venmo, through Creative Artist. All right, so there's the pre-Big Bang theory. That's the string theory.
Why dog overhaul? Why is that?
I think it's like a joke. My string theory is dead.
No, he said May, like May.
String theory is not dead by any means. In fact, they're talking about it right now. There's new evidence to suggest that string theory is because what people don't understand, string theory is so hard to really wrap your head around. But it also, I think, can coexist with some of these other things. I don't think string theory is dead.
For me, the cosmic bounce maybe.
So listen,
Makes
the
sense.
string theory is widely considered the leading candidate for the theory of everything, a theoretical framework that unites quantum mechanics and general relativity. While it is mathematically rich, it remains a hypothesis rather than a proven scientific fact because it currently lacks verifiable empirical evidence.
Okay.
Jimmy, do you know what empirical means?
Mm-mm.
It means like
Empirical.
observable.
Oh, okay.
Like it means like you can Rob, if you'd like to help sponsor our meal today, there's our Venmo.
Oh, okay. That makes sense.
All right, so here is I misspelled four. I put four. All right, so here we go. I think for our first go at it though, like if this just the on the camera comments are pretty cool.
Yeah.
John Scott says, I thought string theory was how Fox Mulder solved conspiracies. LOL. Like pulling at a string, like putting like the conspiracy theories on a board. All right. But string theory is widely considered the leading candidate for the theory of everything, a theoretical framework that unites quantum mechanics and general relativity. So there you go.
So these are the theories for what the
theory is of everything.
Yeah, like how the universe, right?
How the universe
can go essentially happened, right?
How it happened, like how it came into being. Yeah, but string theory is a leading theory. Here's one more question, just so we can have someone can support the channel in some way and let us know in the chat. If the universe is 13.8 billion years old, but the observable universe is 93 billion years old. So So if the universe is 13.8 billion years old, but the observable universe is 13.8 is 93 billion years old. Why does that break the rule of nothingness? Well, here, I'll leave this in here so you guys can see if we can, this will pop up on screen.
Yeah.
Read that for me, Mario.
If the universe is 13.8 billion years old, but the observable universe is 93 billion light years wide, how does that break the rule that nothing travels faster than light? I think it's because light has also shifted in speed.
So if the universe is 13.8 billion years old, but the observable universe is 93 billion light years wide, does that break the rule?
Because I think light used to be faster, I think.
Okay, what do you guys think? Does anybody know this?
But
Sabine Hassenfelder, I'll follow them. Dag Overhaul. I'm not on the other social media sites. At least I had left them about a year ago just for my own sanity. But I do love being on YouTube because I feel like YouTube has got really great content. So thank you guys for subscribing to the channel.
Yeah.
But Mario, give us your answer, and I want to hear it.
I'm just guessing essentially, but I think light was faster than it is now, I think. So maybe that's
good to know, Dag Overhaul.
Although now that I'm thinking about it, it might not make sense for the answer either.
The answer is no, it does not. It does not break the rule. The rule that nothing travels faster than light applies only to objects moving through space.
Okay.
The expansion of the universe is the stretching of space itself, which does not have a speed limit, right? So there's no speed limit of space itself expanding. So the difference between the age and the width is explained by a few key concepts, like stretching space, like the speed of light set by Einstein theory of special relativity dictates that physical objects cannot accelerate past the speed of light through the cosmic fabric.
Yeah.
However, the fabric itself of the universe can expand at any rate, pushing distant galaxies away from each other without them ever moving through space. Then there's the cosmic journey. When ancient light was emitting billions of years ago, the universe was much smaller. While that light traveled toward us over 13 billion years, the space the light was traversing continued to expand. By the time the light reaches us today, the galaxy that emitted it is much farther away than it was when the light started. Like when that light beam started towards us, that very same galaxy is much farther away.
Yeah. Okay.
John Scott Hay says you're onto something with this, Mario.
I mean, I could be making it up. So fact check me on that, John Scott.
Dag Overhaul says calculating infinity is easy. Just take infinity minus 1 and then add 1. Okay. And then there's the current distance. Because of its constant expansion over the last 13.8 billion years, scientists have calculated that the actual distance to the edge of what we can currently see is about 46 billion light years in every direction, resulting in a total diameter of 93 billion light years.
Okay.
So that's why like the universe can be a certain level of years old, but space itself has been expanding. So we're still in this inflationary period. And again, that's what Dag Overhaul was mentioning earlier about like the, entropy, like everything expanding. But again, it goes back to this thing where it's like the universe has been expanding forever. That's the bounce theory. That's the bounce theory. The art says this is boiling my brain. You guys see, this is like super duper intellectual stuff, but it's because the theory of everything that's why string theory is one of the leading theories. Because it's a very big deal. But I'll have some more graphics for next time.
I just searched it up, and apparently light hasn't changed in speed.
Light
overall,
doesn't change speed. It's the space.
But they have to be
space
about
itself.
It.
But space itself is expanding. That's why it's so mind bending.
Yeah.
Because think about let's say you're a galaxy, right? You're a galaxy and you're emitting light. So you're a galaxy emitting light, but what you're hitting, you're moving away from it because space itself is expanding. So your light is still traveling at the same speed, but your galaxy that you're in, or the galaxy that you're observing from, is expanding, and the universe is still expanding.
Right.
And so observably, we can observe that the universe is 93 billion light years wide.
Because I was also wondering, like,
John Scott, I agree.
At what speed was the universe expanding? But as you mentioned, it makes sense that it
can expand at any speed at once.
Right, exactly, yeah.
And it makes sense. But there's a theory that it's slowing down, right? So it's expanding so fast, but it's slowing down because of the Big Bang. Everything just like blew up. Yeah. But that's why Dag Oberhall said that, like, will the universe end in fire or ice? Well, it depends, because they say that everything will end in ice, but the reality is that everything's going to start. It's going to slow down, like, and then it's going to come back.
Okay.
It's going to come back in.
Okay.
It's going to come back in, and then it's going to boom again. But it's going to take trillions of years.
Yeah.
Right. But that's because why did all that stuff condense in the first place? But I think that it's part of a bigger theory, which is like the string theory, which is the theory of a theory of everything. And then listen, we haven't even talked about dark energy.
Right. right. So, fun fact: I was truant most of school. Kids don't stay in school. That's interesting, Doc. Yeah, you can learn a lot by yourself too. If I was
most of school. Kids don't stay in school. Yeah. Truant. What does the word truant mean? Oh, truant. Yeah. Truant means like meaning that you didn't go to class. Truant. All right. Y'all want to hear about dark energy real quick?
Yeah.
And then we're going to go eat something. Y'all go to Jimmy's channel and leave him a super chat and subscribe to this channel. That way we can get monetized.
Subscribe, guys. Yeah.
All right. Dark energy. Y'all, dark energy is the mysterious invisible force that permeates all of space and causes the expansion of the universe to accelerate. Okay. I'm actually going to share my screen with you. So let me see. Here we go. Let's see. I'm using this for the first time, so I'm really excited. So you guys
subscribe for that, guys.
Subscribe for to help us pay for this.
And but yeah, Doc, you can learn by yourself if you're willing to. So
yay! Look at this. This is so great. All right. So you have to remove things from the stage and add things to the stage, etc.
Yeah, okay, we're learning it.
Okay, guys. Okay, dark energy. Okay. Where are we?
Obviously, dark, yeah.
Yeah, we know you're joking. All right, so dark energy is a mysterious invisible force that permeates all of space and causes the expansion of the universe to accelerate. Discovered by astronomer in 1998. I think that's actually surprisingly early, for something that big as dark energy. Permeates all of space and causes the expansion of the universe to accelerate. Discovered by astronomers in 1998 using distant exploding stars called the type La Supernova. It completely upended physics. Before this discovery, scientists assumed gravity was slowing the universe's expansion down. Instead, they found that a cosmic anti-gravity is actually pushing the galaxies away from one another at an ever-increasing rate. So here's some graphics. So there's dark energy and there's also dark matter. The key characteristics of dark energy: they dominate the cosmos. According to data from major astrophysics missions, dark energy makes up roughly 68 to 70% of the universe's total mass energy content. Everything that we can see, stars, planets, gas clouds, and humans, make up just about 5%, if that. The rest is dark matter. Perfectly uniform. Unlike normal matter or dark matter, dark energy does not clump together into galaxies or stars. It is spread perfectly even across the entire fabric of space. So that's also could be a part of string theory. Like that basically this idea that like it is everything. Like dark energy is everything. Like it is the membrane that we're existing on.
Hi, Ian.
Hey, Ian, how are you? Aliens. We went aliens. I can end on aliens. All right. But so it's perfectly uniform. So unlike normal matter, dark energy, dark energy, it's everywhere. As the universe expands, normal matter becomes less dense. Dark energy, however, maintains a constant density. It's weird that they refer to energy as having density too.
Yeah.
This means that as more space is created, more dark energy appears to fill it, pushing it, making its pushing power stronger over time. So that the pushing power of dark energy is never ending and perpetual, and it gets stronger and stronger.
Mm.
So here's an explanation. Astronomers use instruments like the Dark Energy Introspective Instrument. It's DESI.
Mm-hmm.
Dark Energy Spectroscopic Instrument, real thing. DESI.
Okay.
And the data from this to narrow down what dark energy actually is. So it's a cosmological constant. This theory, originally introduced mathematically by Albert Einstein,
Oh, okay.
Suggests dark energy is an inherent property of empty space under quantum mechanics. Empty space isn't empty. It fizzes with temporary quantum particles that generate a baseline, repulsive vacuum energy. There's also quintessence. Some scientists think dark energy is a dynamic, changing energy fluid or field that fills the universe. Unlike a fixed constant, quintessence could change its strength, behavior, and distribution across cosmic time and space.
That almost feels like a
He's like, let me
explanation.
grab the bear. Let me grab Jimmy. Sit up. He's like, let me grab my little thing to help comfort me. And so quintessence. And then there's a flaw in gravity. A final possibility is that dark energy does not physically exist. Instead, our current rules of gravity, or Einstein's general relativity, might fail or change when applied to the unimaginably massive scales of the entire universe. So you can go on and on and on with this, with that.
The quintessence almost felt like a convenient explanation for it, like the ether, because it was like, oh yeah, it bends. It.
John Scott, yes, but it's even deeper than that. So he says dark space could be the multiverse. We just can't perceive it. Yes, it's like a yes and no type of idea. Because why? Because that's even what we can observe or not observe. So it's like if we're all inside a black hole, then it'd be hard to even conceive what's on and the other side of it. Would you rather travel back? Here, we'll end on this. And Rob, if you're here, if you'd like to sponsor our meal, please do. If you guys would like to leave us a Venmo, please do. Would you rather travel back in time to watch the Big Bang happen safely from a viewing ship, or travel to the absolute end of time to see how it all finishes?
How it all finishes.
Oh, yeah.
Why? I'm curious. That's an interesting answer for both of y'all. So the question is, would you travel back in time to watch the Big Bang happen safely from, like, let's say a viewing ship, a theoretical ship? Would you watch the Big Bang happen? Okay. It says, don't look behind you, Jimmy. There's a monster. Or would you like to see how all of time ends?
For me, it's like I don't like missing things. So like the end of it. And also, as we've discussed, there's no point of reference at the beginning of the universe, really, because there's no point to watch it from, really.
Yeah, Dag Overhaul makes a good point. He says the ending is boring and the beginning has no safe viewing. But that's the idea, right? Dag Overhaul is like, what if? I would see the beginning because I feel like I know how it ends. Because I think it ends, there is no end. So I think the end is the beginning. I think the end is what happens like just before it starts to contract again. Because it's like everything ends in like just this entropy, right? Like everything expanding everywhere. And so, but it depends, right? Because people have this idea of like the end of everything being like a meteor, or like, because they're thinking of the end for them, not the end of the entire universe.
Yeah, it's like the end of the world wouldn't be the end of the world. It would be just the end of humanity.
Yeah, or just the end of a planet, or maybe even a solar system.
So yeah, but I agree with Andre, because it finishes because you would know what happened in this world before. Yeah, that's kind of my logic, but I know it's
just what happened in this world before. Okay,
that's kind of my logic, but I know it's like a hypothetical question, not a
like you're hoping that
like we can see to the past, but not to the future. So
right,
that's kind of my.
You guys
my
subscribe,
logic.
and we can see your comments on screen. Yeah, biddings start more exciting than endings. Totally. If the Big Bang happened everywhere at once, does that mean you are technically standing at the exact center of your own observable universe?
Yes, I think.
Yeah, I think there's a lot of truth to that, especially because of like I guess with string theory. Like for example, when you're observing electrons, they can appear in more than one place at a time, right? So the idea is that like things can parallel exist at the same time. So if the Big Bang happened everywhere at once, does that mean you are technically standing at the exact center of your own observable universe? Well, of course, yeah, you are at the observable. You are the observer.
Yeah.
And so much of what we know about the universe has to do with you being the observer,
Yes,
and everything around you.
Because light will travel at the same speed. Will refract to you at the same speed at every point you are looking to. So that's kind of the logic, I think, behind the idea of being the center of the universe.
Yes.
Because there's
Dag Overhaul says most likely we end up with entropic heat death, and then an infinity of inactivity forever. Dag Overhaul, I don't think it would be inactivity forever, because think about it. I don't think the universe is like has a beginning, middle, and end. I think it's nonstop restarting. So I think everything will go out it'll become icy, like what you're saying, but I don't think it'll have forever drift. I think it'll start to recontract at a certain point. Do you see what I'm saying? It'll all start to get pulled slowly back into each other. Because why is like is the universe expand? Let's look at it real quick. Is the universe expanding faster or slower?
That's an interesting question. Well, I will also like to know the answer. But yeah, it's.
So the universe is getting the expansion of the universe is still getting faster, while gravity tries to pull together matter and slow the expansion down. A mysterious force called dark energy, again, dark energy. Dagobah says, and you want it to be cyclical to resolve the conflict of where beginning of a point origin. So the dark energy, it counteracts gravity, right? So dark energy acts as a cosmic repulsive force that pushes space apart, and is currently winning the tug of war. So the tug of war between gravity and dark energy. So dark energy is winning. So the timeline of cosmic speed, the universe has actually experienced both phases during the 13.8 billion year history. The slowdown. The first 9 billion years, early on, the universe was dense with matter. Gravity was strong enough to act as a brake, gradually slowing down the expansion rate. And here I can go here and show this.
Yeah. That's interesting. The idea of gravity being the brakes.
Yeah. And so the speed up, the last 5 billion years, as space expanded, matter thinned out and gravity weakened because dark energy remained constant in density as space grows. It eventually overtook gravity. Dag, overall, help us out with the super chat over on Jimmy's channel. It would help us out a ton. Or Dag, if you want to help us out on any other means. Jimmy, what's the best way to support the channel?
Venmo.
But he's outside the country. Dag Overhaul is.
Wise.
So Wise is a good place, or PayPal. But the last 5 billion years, as space expanded, matter thinned out. So matter itself thinned out and gravity weakened because dark energy remains constant in density, even as space grows. It eventually overtook gravity. About 5 billion years ago, the universe shifted gears and began accelerating. So... So in 1998, 2 independent teams of astronomers measured the light from faint dying stars we talked about this before. They're called La Supernovae. They expanded to find that the expansion was slowing down. And they thought that they expected to find that the expansion was slowing down. And this is what blew their mind. Instead, they discovered that stars were much farther away than they should be, proving that the expansion of space is actively speeding up. This groundbreaking discovery earned the researchers the Nobel Prize for Physics in 2011. So it took them literally 14 years or so, or 13 years to from the first discovering it to like proving it. So they won the Nobel Prize in 2011.
That's recent. Yeah.
Very, very recent.
Yeah.
But if you think it's important for us to explore these topics, then subscribe for more. Dag Overhaul says the expansion is speeding up, so there's no possibility of a big crunch. Well, who knows? Who knows, Dag Overhaul? If we're living in a simulation, that's another theory, right? If we're living in a simulation, then that dark energy, there could be some force that's perpetuating that dark energy.
Good night, Andre.
Ian says, good night, Andre. Is this what they call the God particle? No.
There's a linear collider called LIGO near me. It detects invisible gravitational waves from deep space. Ooh.
Interesting, Ian. All right. The God particle is a popular media nickname for Higgs boson. It's a fundamental subatomic particle that was first theorized in 1964 and officially discovered in 2012 by scientists at CERN. So the year Jimmy was born. So here is this, guys. All right. So Jimmy, this is we're talking about the God particle. And then we will end on the God particle because it's God, right? The ultimate, right? The God particle. So it's the Higgs boson. That's why we call it like the Higgs, the CERN's Large Hadron Collider. It is considered one of the most important discoveries in modern physics because it is the physical proof of an invisible energy field, the Higgs field, that permeates the entire universe and gives mass to all other fundamental particles. Why is it so important? It gives matter mass. Imagine the Higgs field as a cosmic pool of thick molasses. Okay, fundamental particles like quarks and electrons have to swim through it. The resistance they face as they move through this field is what we experience as mass. That's crazy. Okay. But that itself is what we experience as mass. But it just goes when you get to the subatomic level that nothing is what it seems. So the God particle is the Higgs boson. Without it, life could not exist. If the Higgs field did not exist, subatomic particles would have no mass at all. They would have zip. They would zip through the universe at the exact speed of light, unable to bind together. There would be no atoms, no chemical elements, no stars, no planets, no life, nothing without this God particle, which is called the Higgs boson.
Okay.
All right. It's the standard model. The Higgs boson was the final missing piece of the standard model of particle physics, which is the foundational mathematical blueprint scientists use to explain how the subatomic universe works. And then where did the nickname come from? The nickname had nothing to do with religion, and most physicists actually hate it. The term originated from 1993 popular science book by Nobel Prize winning physicist Leon Letterman. Letterman originally wanted to call it the goddamn particle because it was so frustratingly difficult and expensive to find. However, his publisher objected to the profanity and edited it to the God particle, mistakenly leading the public to believe the particle had spiritual or theological significance. However, you could argue that it does. You could argue that it does have that level of significance, this God particle.
Okay, yeah.
But the publisher was the reason why they changed to the God particle. But it's massive yet tiny. It is roughly 130 times heavier than a proton.
Okay,
well, it has a unique spin. It is the only known fundamental particle with a quantum spin of exactly 0. So it's zero spin. Once created in particle collisions, it survives for less than a trillionth of a billionth of a second before decaying into other particles. So it decays into other particles. But they call it the God particle. But it's so tiny. But it's how we experience what is mass. And again, imagine it's a cosmic pool of thick molasses. And the resistance that anybody feels moving through this field is what we experience as mass. And no life could exist without it. So that's a big deal.
Yeah.
Okay, guys. Don't forget to subscribe to this channel.
That was really interesting.
Very interesting.
Yeah. Although, yeah.
Like, simulation theory is unfalsifiable, says Dag Overhaul. Yeah. Simulation theory is an interesting one. All right, guys. We're going to do the countdown. Yes.
I'm going to solve this Rubik's Cube real quick. Hold up.
All right, it says try making the universe without electrons. No luck because electrons are the God particles, says Dag Overhaul. I think it's amazing that we as human beings have been able to even get that far to the subatomic level, right? Like we've been able to get to the atomic level, and then we've been able to get to the subatomic level. That alone is a huge achievement for.
Like, how do you even measure the fraction of a second? So it's like, I know there are ways, but it's just like the idea of it.
John Scott says, doesn't the God particle unify all theories if it exists? No, John Scott, like there isn't, like the God particle is it's a popular nickname for the Higgs boson, which is a fundamental subatomic particle that was first theorized in the 60s, but then discovered in the year Jimmy was born in 2012. Mm-hmm. And it was discovered.
Jimmy is the God particle.
But it immediately decays and like becomes a part of other particles. But it is a subatomic particle. But it's very, 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 very tiny.
It doesn't.
So John Scott, that would answer no. But it doesn't result in a grand unified theory alone. You're right, Dag Overhaul. It does not. It's more just like that is the ultimate subatomic particle, and everything that we exist as mass is because we're passing through that. I'm sure that more information will arrive, especially even just with the use of AI, right? With the way that we discover like technology. So thank you guys for supporting our channel. We're human beings just like everybody else. We got to pay our bills, all those different things.
Thank you guys.
So thank you all for supporting us so much. We appreciate you.
And subscribe to these channels
subscribe
as well.
To the channel because we've got to get this channel monetized. We really do. So even Jimmy, I'm trying to help him understand the importance of it. So guys, all particles are important. Don't pick the non-Higgs bosons. Don't pick on the non-Higgs bosons. You're funny, Dag Overhaul.
Right.
But if you guys would like to participate in the channel and you guys would like to see your comments on screen and help us, pick the plan for the live streams, then participate. It's a really awesome experience to learn live with the audience.
So interact with you guys,
John Scott says he got to learn again.
I got learned again.
I got learned. You got learned. That's what they used to say right back in the day. Like, you got to get learned. So getting learned is a big deal.
Yeah.
So thank you guys for subscribing. Thank you for being here. The art. Dag Overhaul.
Thank you, Andre.
Rob, are you still there, Rob? Rob, are you still there? If you are, you'll be our last pin comment. All right, we're gonna do the countdown. 10.
Wait. I'm solving the Rubik's Cube. Just give me 1 second.
10. 9. 8.
Guys, don't forget to like the video.
Yeah, don't forget to like the video.
Dag Overhaul, you're number 1 on the fan list.
I'm on a new program, so I can't see over here like who's number 1. But Dag Overhaul, I'm gonna follow Sabine Hostenfelder. So Dag, does that deserve a super chat?
Sabine. But yeah, you're number 1. And Dag Overhaul, David Young is number 2. John Scott, you're number 3.
And then we have to figure out, Mari, did you try to leave a comment? Did it work?
Here,
because you were remember how you were telling me that like your comments are being hidden
on posts and videos.
Boom! Look at that! I solved the Rubik's Cube.
Wow. You guys see Jimmy is a smarty pants.
That deserves.
Come on, that deserves a Venmo. Jimmy,
look at that.
So I mean, he really did.
He really did that. He really did that while we were sitting here. I don't think I've ever solved a Rubik's Cube. Mario, have you?
Yes, but I forgot how to.
I don't know if I ever did. I don't want to lie and say that I did because I don't have any recollection of doing that.
I learned when I was a kid, but then I forgot. And
so Jimmy, what's the trick? Tell us the trick.
So this white part, this sticker where like the white, you always want that facing up.
So you just had to pick a color because wouldn't white be just as same difference as green or the others?
No, because white has to be on the top because that's where like the main that's where the logo would be. So okay. Have that facing up.
Okay, gotcha.
Dag Overhaul said, "Nah, Jimmy, you just replace it with a pre-solved one of camera."
We don't even have another one. This is the only one.
It says, David Young says your phone helped you. Did your phone help? Did you ask it for help?
No, no.
I mean, it'd be okay if it did. Does it?
Yeah, I downloaded an app to do it.
Well, it didn't, but the app didn't like grow fingers, right? John Scott, it is tough. It is tough.
I don't know which
It
way
is.
he means.
It says Dagover says, yeah, someone super chat for me because I'm broke. Dag Overhaul, how can you be so smart and be broke? Are you in a situation like us? Did you lose your house or something? Or just the life happens, right? Life is expensive, right, Mario?
Yes.
Isn't it surprisingly how expensive just to live?
Yeah.
It's pretty wild.
The more you grow, the more you realize.
The older you get, the more you realize it's like, oh, like everything has a cost, and it's like, oh dang. Dag Overhaul.
Help
Dag
me
Overhaul.
solve this.
I feel you, bro. I feel you. I know the feeling of losing everything. Before that, I had lost everything back in 2007, 8. Just it's crazy, but you can rebuild, right? Dag Overhaul. David Young says he lost his snacks. All
right, now Mario, I'm gonna
John Scott is claiming
it
that
up.
that's a stunt cube. Mario, can you do a proof that is a real Rubik's cube?
It's a cube.
It's a
I
real.
just
It's a
mixed
real.
it up,
That's
okay?
hilarious.
Look,
that
I
you-
just mixed it up.
Like it's
Okay.
not a fake cube, John Scott. But
Look,
that is
look, guys.
funny. That is hilarious.
It's mixed it up. Yeah.
Okay,
it's-
look, I mixed
It's
it
a
up.
legitimate.
Look, I mixed it up. Okay.
Yeah, it's a legitimate cube.
Bam.
Rubik's cube.
Bow.
You guys leave
Boom.
a comment and we can put it on screen.
Bam. Solved. Wait, not yet.
Not yet.
David Young has
Now
lost his
it's
snacks.
Solved. It's solved it, guys. Live.
So what's the trick? Because I don't know the
The first
I
trick.
don't know the trick.
From what I remember, is the first solve one side,
Yeah. And then you want to go.
then solve like the following level,
Mhm.
and then there are some combinations that you can make after that to fully solve all sides. But so that's where I get stuck. But there are some movements that are conceived to solve the Rubik cube. Like if
I had a friend on my soccer team, and a half time, it would just get his Rubik's cube and solve it in like 5 seconds.
Well,
Got
I mean,
it.
it's,
And like we could mix it up. He's like, "You guys go mix it up." And he's like, "Okay, all right, solved."
What do you mean, Dag Overhaul? You said there are algorithms, Brett.
yeah, to like solve the
Rubik's
Rubik's cube. Yeah.
Oh, interesting.
But these ones are extremely hard.
Oh yeah, these are harder.
That one, I actually put it. I was putting it over here because I was like more. All
It
right,
looks
Dag
more-
Overhaul. This is for you, Dag Overhaul. Just because I don't think the food is quite here yet.
No, it is.
Do you think the universe will expand forever till everything freezes, the big freeze, or eventually snap back and collapse, the big crunch? That's what Dag Overhaul was referring to, was the big
Uh-oh.
crunch. And if somebody asks for aliens, I'm going to show some pictures of aliens before we go.
I think. Well, I want to know Zach's answer too, but I think it will keep expanding until it freezes.
Okay, so
Seems way more likely given physics. Yeah.
can you guys hear? There's like a subtle, relaxing music in the background too, and I'd like to
Can I
know if y'all
solve
can
that
hear
one?
that. We're not going to be able to hear it in the studio. Only I will, but I don't know if the audience can hear it.
Let us know, guys. Jimmy's right. The new generation cubes are insane. Yeah.
Yeah, those are
Did you know that, like, as of right now, they're still debating this? Okay, they're still debating, and as of like we're in the middle of 2026, right?
Yeah.
So as of mid 2026, the scientific consensus on the fate of the universe is a
Yeah.
state of active flux. The big freeze was the dominant theory for decades. The
Okay.
big freeze.
Yeah.
Okay.
Like this is what that one's supposed to look like when it's solved.
Right.
All right. That's so funny because I'm like have this music in my head. It's like things are
Look.
playing out. But I'm glad that Dag Overhaul says no worries on the and they're infinite universes anyway. They're so true. But the big freeze was that means eternal expansion was a dominant theory for decades, and widely publicized research from late 2025 and early 2026 has significantly strengthened the case for actually the big crunch.
Okay.
So
Very good look
as
at
of
this.
the
Don't try to get
last
it
6 months, the big crunch has been taking over. Why? The case for the big crunch is the emerging view. Recent data from the Dark Energy Spectroscopic Instrument, the DESI, and the Dark Energy This is news to me, Brent. I have to look into that. Look it up right now, Dag Overhaul. Look it up on your laptop, or look it up, because I want to debate with you about this real quick before we go. So check this out.
Bye.
Check this out. All right, the case for the big crunch. Okay, guys, this is the case for the big crunch. All right, so Mario, let me know what you think about this. Recent data from the Dark Energy Spectroscopic Instrument, or the DESI, and the Dark Energy Survey has challenged the standard model of cosmology. Jimmy is simulating the big crunch. That's funny. These findings suggest that dark energy, the force driving the universe's expansion, may not be constant. The mechanism, if dark energy weakens or switches signs, becoming negative, gravity could eventually overpower expansion, pulling the universe back together. So the timeline, a widely cited model published by Cornell physicist Henry Tai in late 2025 suggests the universe may be approaching the midpoint of its life. Wow.
Whoa. That's
crazy.
Sad.
Well, it's not sad. I mean, it's more like but it's never ending, right, Mario?
Yeah.
It's forever expanding and contracting. If you guys are here, don't forget to leave a comment and it'll be on screen. I liked the big crunch. It sounds like a candy bar, John Scott.
Totally.
Absolutely.
Yeah.
The timeline. Under this model, the universe is not infinite, but it is a temporary cycle that will eventually snap back into a hot, dense singularity. Going back to what I was saying, Mario, about this forever expanding and forever contracting.
Yeah.
And I hope YouTube pushes this out to people, because this is an educational live stream, and it's not just like, everyone's playing video games. I think that that's fun, but I think there has to be an audience for something else, Mario. What do you think?
Yeah, same here.
There has to be something just beyond video, like constant video games.
Yeah,
I think video games are wonderful, but I think everyone playing video games around the world.
Yes.
Mario, do you want to tell everyone what we did before we came live today?
Well, we were just seeing what was live on YouTube, just to also kind of see like what are people watching.
Yeah.
And we essentially noticed that there was a lot of gaming live streams.
Like it was only gaming. Like it was not only gaming. I would say over 50%.
Yeah. And again, games are fun. Yeah. But there's also like this amazing audience that learns with us and discusses these things. So if you guys have any friends that you might think would like this channel, also go share this channel with those friends, because we want to reach the people to learn along with us.
Yeah, we want this to be like something that people can enjoy.
Yeah.
That's beyond just your standard just playing video games. It's like actually like learning something besides like how to win the next hack to get to the next level in the video game.
Yeah.
But I think video games also kind of reinforce simulation theory. And the reason why is because in simulation theory, thank you, Ian. He says double likes.
Thank you, Ian.
So because people want to live in a simulation, they don't want to live in the real world.
Okay.
They want, you know what I'm saying?
Yeah.
Like they want to be more and more in this virtual land.
Right, because there you can also,
you can do whatever you want.
Yeah.
All right, so the case for the big freeze. So, but under the new model, the universe is not infinite. But the case for the big freeze, Dag Overhaul is a big freezer guy. Until the recent findings, the overwhelming consensus favored the big freeze. Okay.
Thank you, Ian.
Up until recently, what did Ian say?
I see what he did. He's on both of his accounts to like the video.
Oh, thank you. That's so sweet of you. Thank you so much.
You, Ian.
And thank you to YouTube for being such a big champion for Jimmy Explores, because YouTube has really been so wonderful. Because if you guys know Jimmy Explores, we just started on Jimmy Explores and he's almost at 15,000. And after this, we're going to eat and we're going to go live on Jimmy Explores. But we have to grow this channel as well. All right, so this one's much more intellectual. Would you say, Mario? I feel like we're like coming in strong.
Yeah.
Like we're like even Jimmy is over here solving Rubik's cubes. Okay. Like even Jimmy is like really impressing us over here. Okay, so all right, let me show you guys. All right, so this is Dag Overhaul's take. He likes the big freeze. So you guys, the big idea is like, will the universe end in ice, or will it end in a recontraction? The recontraction is the big crunch. There's new compelling. This is the emerging view. is that it will end in a big crunch. But the standard model, up until just the last 6 months, everybody was like under certainty, like everything will end in the big freeze.
Mhm.
That's why it's news to you, Dag Overhaul, because literally this is brand new. Dag Overhaul says, my AI is saying it's between the big freeze and the big rip, and that the big crunch is indeed dead. Recent data, though, Dag Overhaul, maybe that's like the AI, the AI. What do you call it? I don't have an actual. I don't have a personal preference, right? But the case for the big freeze. But Dag Overhaul, I love that. Thank you for being so intellectual and commenting. Like literally, I appreciate you so much, Dag Overhaul. And you guys, we know Dag Overhaul. Dag Overhaul he's amazing. He's such a good friend. So thank you, Dag Overhaul. Until the recent findings, the overwhelming consensus favored the big freeze. This scenario assumes dark energy is a cosmological constant, or lambda, that pushes galaxies apart with constant and increasing strength. The outcome is that in the future, the universe expands forever, stars burn out, black holes evaporate, and temperature approaches absolute zero, resulting in heat death. That's what Dag Overhaul said at the very beginning of this. He said heat death.
Yeah.
I'm running Opus on Max, reasoning with deep research mode for that. Nice, Dag Overhaul.
Opus. Okay.
I love it. All right, so in this future, the universe expands forever, stars burn out. Can you imagine that? Black holes evaporating? Wow. I mean, a star dying, sure, we see it, but we've never seen like a black hole evaporate, right? Because of our limited ability, the way we perceive time and the way we can experience time. And the way that we are able to even experience anything is because of light. Thank God we have eyeballs and then we have telescopes.
Yeah.
And that's why we love cinema. And that's why we love doing YouTube so much, is because everything at the end of the day is like light, right?
Yeah.
Photography is like capturing light, right?
Yeah.
Like what light is. And Dag Overhaul, you and I should do a phone call, because I would love to talk with you about, if you lost everything, Dag Overhaul, I did too. We can make it back together. Great minds think alike. But I don't have a preference on how the universe ends. I'm fascinated by all of it.
I like the big rip. That's something interesting.
Yeah. But in this future, everything is heat death. There's no thermodynamic energy remaining to sustain life. Many physicists still support this view, like Dag Overhaul, arguing that while the new DESI data shows deviations, it is not yet conclusive enough to completely overthrow the standard lambda CDM model. So Dag Overhaul, this supports what you're talking about here.
I mean, I like the idea of a big crunch.
I mean, I like the idea of a big crunch. I don't even like the idea of a big crunch. I don't have a preference at all. Like, I think it's all interesting. The big rip. The big rip is a hypothetical cosmological scenario where the universe expands so rapidly that it literally tears itself apart down to the subatomic level. The mechanism, unlike the big freeze, where expansion continues gently forever, unlike the big freeze, where everything expands gently forever, the big rip requires a specific type of dark energy called phantom dark energy. Accelerating acceleration. In this scenario, the density of dark energy increases over time rather than staying constant. It keeps getting faster. So it's accelerating the already acceleration that's taking place. It overpowers gravity. Let's see here. All right, increasing over time, staying constant. Overpowering gravity. As the universe expands, the outward push becomes infinitely stronger, progressively overcoming all binding forces in nature, everything. The timeline of the destruction. If a big rip does in fact occur, the destruction happens in a specific terrifying sequence as the phantom energy overcomes increasingly stronger forces. Galaxies are separated, solar systems are dissolved, planets explode, atoms are destroyed. In the final fractions of a second, electromagnetic strong nuclear forces fail. Molecular atoms and nuclei are torn apart into isolated particles. The end of spacetime. Finally, the fabric of spacetime itself is ripped apart at an infinite expansion rate. This sounds like the worst case scenario. Like not even a star makes it. It's like boo boo,
Like,
not even a
no.
star boo.
Like it's over.
Like
no hope.
nothing. Like nothing can survive the big rip. So the big rip, that does sound like the ultimate death, right? Because the big freeze and the big crunch, it sounds like there's a potential future, right, for things to expand, right?
Life to keep, yeah.
But the big rip is like I guess the scariest scenario of them all.
Yeah.
Phantom energy, phantom dark energy. Are we sure this is not Star Wars? Dag Overhaul, you know phantom dark energy is real. You know that's a real thing. That's undisputed. Look that up. Phantom dark energy. If you don't already know about it, it sounds like doesn't Dag Overhaul sound like he's a physicist already? It doesn't. It's not really all that speculative, John Scott. There's the big rip, the big freeze, and the big crunch. Mm-hmm. But they do all sound like snacks.
Yeah.
Except for the big rip. Maybe that sounds more like letting one rip. While the big rip remains a valid mathematical model, it is generally considered less likely than the big freeze or the big crunch. Recent cosmological data, like in the 2025, 2026 results, suggest dark energy might be decaying or changing rather than growing exponentially forever. So the big crunch is gaining ground. It really is. It says, yeah, Brent, it's fun how physicists make up these terms. Sounds like sci-fi, but they are real. I'm glad Dag is like, I'm not, I never come on here to like fight with people because it's like, it's more about like how much can we learn in an hour or two?
Yeah.
Right. All right. So look at all these Rubik's Cubes for Jimmy to learn from. So thank you to Rob. Thank you to Dag Overhaul. Thank you to John Scott. Thank you to everybody who's watching. If you guys have not already subscribe because it's a channel where you're going to learn a lot.
Yeah, and this is going to be really interesting discussions.
Yeah, it's going to be a great channel. Y'all are going to love it. It's very, very cool. This is my first time ever using this. For being my very first time, I'm impressed that there's anything going on over here because this could just be total chaos. But how did I do, Mario?
No, it was great. Yeah.
Were you surprised? Were you thinking it was going to be the total disaster?
No. Because I think, your tools.
I'm like, I can learn fast.
Yeah.
But I didn't have any practice with this at all. I'm like,
right.
What is this? I'm like, what's going on over here?
No, but it was good. And chat, let us know if your comment was featured, if you would like to be featured as a comment on the next live.
And Dag Overhaul, what do you think about Jimmy XP? I don't know. I think XP, I think that should be for something else other than gaming because everyone is gaming and it just feels like it's so overdone. But what do you think, Dag Overhaul? What do you think about the gaming channel? I feel like I love the name Jimmy XP. Like I think the name XP is a great name, but it makes me feel like he should be doing something else. Like with that channel, like it should be like Jimmy X, like something like a science experiments or something like that. You know what I mean?
Mm-hmm.
All right. It says Brent, what do you have next time? Do Rubik's cubes. Brent would have to be next to him for Jimmy to do Rubik's cubes. Why? Is that to make sure he's not getting any assistance? What do you mean, David Young? Tell me what you mean. I'm curious. What your take on that is. Okay. All right. Mario, I'm going to ask you 2 more questions because that's what I have on my list here. All right. Do you think the universe, we already answered that one. If scientists prove tomorrow that the universe is just a digital simulation created by a more advanced civilization, how would that change your daily life? This is a good question. Dag Overhaul says, I think Jimmy XP should be the channel where Jimmy has fun on his own terms. He can't because he's a kid, so they won't let him. So, I mean, unless it's just, it may be pranks. I like the idea, Dag Overhaul. You make a good point. Like where it's just, that's a really good idea though. Like just like total chaos on Jimmy XP. I'm not against it, Dag Overhaul. All right, so here's the question. Here's the question. If scientists prove tomorrow that our universe is just a digital simulation created by an advanced civilization, how would that change your day-to-day life? How would that change your daily life?
I guess it would be like more how do you say, like more relaxed, but that's not quite a word. Because then I would have no self-determination really.
Mm-hmm.
And I do think us humans have some self-determination.
Mhm.
So maybe I would just start caring less, because I would be like, oh, someone's controlling me, or I'm determined. So maybe, yeah. But I do think we do have self-determination. So I still care, about like the things we do.
Yeah.
Um,
I mean, in a way, like, is there any real difference? I mean, there's an argument there that it's not really like there's not like a legitimate difference. Like,
well, yeah, because you could argue that we are also programmed to be that way. So, but yeah, I guess it would be. I mean, I'm thinking like of that on the question. So
yeah, I mean,
but
it's a legitimate question. Is anybody in the chat? I'm looking for some new footage here.
My keyboard has a space bar. I wonder what happens if I press it. Hey, Rich San Diego. If it's a simulation, I would try to find the exploit for privilege escalation.
Who said that?
Dag Overhaul.
So Dag, where are you watching from? Because Dag,
Sweden.
So you're watching from Sweden. So do you feel like do you not have the privilege that you need in Sweden? Let me know. I'm curious. Like, do you feel like that there's like a certain level of privilege that's needed there? I'm impressed with this program that allows me to add different things quickly.
Yeah.
For me, it wouldn't make any difference because I already half believe that. It says Daggerwell says it's hacking term, Brent, for becoming an admin, basically. Okay, so privilege, is that what you're talking about? Privilege
escalation. Yeah.
Okay, got it. All right. Rate this concept from 1 to 10. The idea that the Big Bang was just the result of two higher dimensional brains or membranes, because they use the word brains, colliding in a multiverse. They talked about this literally like less than like 5 days ago on Star Talk.
How does it say there's no solution to this?
Mm-hmm.
I'm saying I try to become God, says Dag Overhaul. Gotcha, Dag Overhaul. Dag Overhaul, somehow I can believe that about you. Dag Overhaul, I can believe that. All right, rate this idea from 1 to 10. The idea that the Big Bang was just a result of two-dimensional brains colliding in a multiverse.
What's a brain? Like,
it means like a membrane.
Okay. Oh, colliding into multiverse. For me, I would rate it maybe a 7. Just because the multiverse theory, I don't know, I think it has been misinterpreted.
Yeah.
And so I have the idea that we typically see on media, but I need to honestly look more into that because...
Ian's head is exploding. Okay. Star Trek-ish, yes.
The Star Trek-ish, yeah. Like a tectonic plate.
The idea that we're describing is known as it's what I was mentioned earlier. It's the ekbicrotic universe model. It's the cyclical brain world scenario. Brain as in membrane. Because again, brain is like, it's almost like a string, right?
Yeah.
So it is a major alternative to the standard cosmic inflation theory developed by physicist Paul Steinhardt, Neil Turok, Justin Hori, and Bert Overt in 2001. Instead of the universe starting from a single infinitely dense point, like a singularity, this theory uses string theory to explain the Big Bang as a cosmic collision between higher dimensional surfaces. Okay. So there are higher dimensional surfaces. Here's how the idea works, broken down step by step. The multiverse is a bulk. In string theory, our 3 dimensions of space, up, down, left, right, forward, backwards, plus 1 dimension of time, are not all that exist. The bulk, there are higher 5-dimensional spaces called the bulk. The brains are floating. Brain is short for like membrane. Floating inside of this bulk are 3-dimensional surfaces called brains, short for membranes. Our reality, Mario, our reality is our entire visible universe, all its stars, planets, galaxies, is trapped in just one of these brains or membranes. We cannot see it. We cannot see into the bulk because light and matter are stuck into our brain like flies on flypaper. And so the collision the collision is the Big Bang Theory. According to the epicrotic model, our brain, our membrane that we live on, is not alone. There's another parallel brain floating nearby in the bulk, separated by a microscopic distance between the fifth dimension. Over vast eons, our gravitational attraction pulls those two parallel brains towards each other. And when the two brains inevitably collide, the titanic energy from the impact is injected uniformly across both surfaces. The result is that this kinetic energy instantly converts into a hot, dense soup of matter and radiation. From our perspective inside of our own brain, this violent collision is what we call the Big Bang.
Okay,
And
yeah.
it also solves a lot of cosmic mysteries because physicists love this model. They really, really love it. Physicists love this model because it elegantly explains two major mysteries of the universe without needing inflation. The inflation theory, the idea that the universe is expanding faster than light right after the Big Bang. The flatness problem, because brains are flat, smooth surfaces before they collide, the resulting universe is naturally flat and uniform after the collision. In the horizon problem, in standard cosmology, opposite sides of the universe look identical, which is hard to explain because they are too far apart to have ever touched. In the brain model, the two sheets had plenty of time to smooth each other out via gravitational forces before they ever even crashed. And it's a never-ending cycle. The theory evolved into the cyclical model. After the brains collided, the force of the impact crushes them apart. As they separate, the universe on our brain, or our membrane, expands and cools, eventually forming galaxies and stars. Eventually, dark energy takes over, stretching our universe out until it's virtually empty. Then the attraction between the brains pulls them back together again. They collide, trigger a new Big Bang, and the cycle repeats forever, meaning there are no true beginnings or ends of time. And that is the most ultimate one. Like the most ultimate concept is like that theory, but that comes from the big rip comes from that. There you go. Jimmy should do first-person perspective live, showing his hands without adults, solving Rubik cubes, for example. He can't be anywhere without adults. Showing his hands, could do first-person perspective lives, showing just his hands without adults, right? Yeah, but I don't know how many people just want to see hands. But who knows? But well, this is very, very intellectual live stream, but I think we had to touch the topic at some point. So we had to talk about the end of the universe at some point, but so we went ahead and covered it. We were like, you know what, let's just go there. Thank you, Dag Overhaul.
I mean, the conversation is like always evolving, and you can always like find new things. So
absolutely,
that's another reason why it's interesting and why it's like evergreen.
It is
in that sense.
All right. Well, we're ready to go. Ready, Jimmy? Do the countdown with us. Ready? 10, 9, 8,
7,
6,
5, 4, 3, 2, 1, 0.
2.
Thank you guys so much. Don't forget to subscribe. This is our first time using this software, so thank you guys so much for
the video, guys.
Thank you, Dag Overhaul. Thank you, David Young. Thank you, Rob. Thank you, everybody.
Thank you, Dag.
Bye, guys.
Thank you so much, guys. Thank you, John Scott.
Bye, John Scott.
Bye, John Scott.
Bye, David Young.
See ya.
Bye.
Thank you, guys.
All right, I'm doing the outro. You guys don't forget to subscribe.
Thank you, guys. Like the video as well. Subscribe.